Okay, I pressed the button and we were ramping up in bits per second, settling out at 2,664 kilobits per second. Hey there. Let's see, this is stream number 16. I'm working on a tool. Excuse me. I'm working on a tool that I can use to parse data. So, been thinking that I should probably record like a recap or an intro that I don't have to say it every single time. I can just point to the repo. And haven't decided if I'm going to do that just by taking a clip of the stream or recording it special. Anyway, where I left off yesterday was I have all of the lex are done and all the parse are done and all the tests are passing. Woohoo! So let's see. Where to begin? I guess I'm just tired of doing a recap of what I'm doing. I don't want to have to keep repeating myself. So maybe the first order of business should be to record a good recap. And then I guess from the recording that I'm making, I can extract just the salient part and post that as a separate YouTube video. So let me think. Maybe I should just gather together the pieces and the things arranged on screen that would best describe it. So if I take this example file and I like put it off to the side, cancel, close that. In this panel, put that, and then open this up, I guess, and run actually I can have hold on, I don't want to actually pipe it to a file. I want to do less. That's not as well. I guess we can do that. Nah, I don't think that's a very useful one. Let's pick what I want to do is decompose. Yeah, this one. Yeah, I want to have that one on one screen, and then I want to have another terminal that's kind of showing I think the output of the Lexer would be nice. Yeah, that. Okay, so if I have these two shells, then I can kind of talk about how this is the domain-specific language. This is the data we're parsing. The tool uses that language which describes the data and uses it to parse the data and assign meaning to different bytes, right? And I can say the first stage is the Lexer. I'm just thinking, should I spend time on cleaning up this output so it's easier to read? I don't think so. I think this is fine. Then what's like a succinct way to like show off the part, just the compiler, just the abstract syntax tree. Maybe make another shell. I just didn't like this output so much. I think it's because it's showing application extension, it's not showing GIF. But if I like searched for plus GIF, actually it would be plus GIF. it would be backslash plus GIF because backslash is a symbol for regular expression, and that didn't find it. Oh, GIF doesn't have a plus in front? Oh, right. Yeah, okay. I just misreading it. Maybe if I leave it right there, then we can kind of see how it got interpreted as the abstract syntax tree. I guess I'd want to do arrows down. So if I arrange the shells in this order, with Lexer, parse. I want to avoid using the word parser because it's ambiguous. So what would it be like? Lexer. Let's use the word, avoid the word Lexer too. I can just say that there are 3 stages to the tool. The first stage turns the format description into a sequence of tokens. The second one, I think here I want to show the grammar. Parselex, hey there, Mad. Stork, 91. I think I want to have another tab open here to quickly flip to it, or maybe over here actually. The grammar, and then maybe put it like right, yeah, put it like right there. Parlex equals like parlay. Did you come up with that term, or is that already defined somewhere? Just came up with it. Not bad. I'm just thinking about how I'm going to make an intro video to the project I'm working on, because I need that, because everyone coming into the stream asking me what I'm doing, I have to keep re-explaining, and I've decided that that wears me down, and it also probably is redundant to people watching. And sometimes I describe it well, and sometimes I describe it poorly. And then there's I have self-reflection of that, thinking, you know, why am I doing this? Same thing like in coding. If you write the same thing 10 times, you start to wonder, why am I copying and pasting this when I should refactor it into having it in one place and calling it from 10 other places, right? So if I make one recording describing what I'm doing and then just link to it, and then when someone comes in and says, hey, what are you doing? I'll just do quickly the command project, and it would like have a link in it. You can give an intro and clip it. That's one thing I was thinking of. So that's actually what I'm thinking about doing right now. What I do is note down somewhere. Should I do it on paper, or should I do it electronically? I have to note somewhere around the time we decided to start recording. And then later when I go back on the VOD, I just go to that point. I wouldn't even use the clip feature. Although I wonder, maybe I should give Twitch a chance. There's a clip that button. Maybe I can hit that myself when I'm done, and I try to do it within, I don't know how long a clip can be, 60 seconds? Parlex USA LLC is a semiconductor, so someone's already come up with the name. How unfortunate. We can't trademark that name now, right? Hey there, Destrin. Those are the commands. And we're talking about turning the project command into something more informative, like it would have a link to watch a short video that gives a overview of what I'm working on. Cannot trademark it, but we can name the function. That is true. Okay, let me get myself ready for this. So we're not going to need to show that file. Not that file. Not that. So we're going to put a format straight on this screen, and maybe, yeah, maybe like this. I want a little bit more room when I'm showing that, though. You know what I can do is I could squash this for now, because that gives me a little bit more room vertically, and it cuts down on this on the noise. right? Because now I can show signature version and screen width from logical screen without moving the scroll position anywhere, right? And optimally, I want to freeze that window right there to show the format, right? Or no, formats. I want to show that. This window's too little. That's a little bit better. I think when I show this window, I'm going to be scrolling down a little bit. Yeah, this isn't too bad. It's cut off a little bit, but that's okay. I could always, like when I switch over here, I can widen it like that really quick. It's already a thing in something. The format is parse lex. Well, lex and parse are two verbs that are used quite often in these compiler stages. Okay. Here's the problem with recording something. If I screw up, I'm going to have the urge to like do it over again, or I'm going to want to correct myself. And that's okay because I'll end up editing it. So I have to remind myself, if I screw up, I can just take a pause, which will help me as an editor later. A pause, maybe do some kind of signal like put up my hand so that if I see that in editing, I'll know to go back. Yeah. See, what I found in editing videos is that if I make a mistake and I just repeat the last sentence or last two sentences later as an editor, it's hard for me to find those points where I have to cut it. And I kind of wish that my past self would have given me my future self a cue, like, okay, stop, and then give a little bit of a pause so we can go back. Oh, and the other thing is to avoid jumps in the cut, like jump cuts, jumping around too much. I have to avoid like moving around too much or moving the scroll position of this too much. And especially if I screw up, I should like freeze, not move the mouse, so that when we go back and re-explain it, there won't be too much of a jump, right? Okay, I'm getting myself psyched to do this. Why is that highlighted? Oh, because the cursor was sitting there. Set the cursor there. Okay, same thing here, right? Need to set the cursor somewhere neutral. I guess sitting right there is fine, right? Seeing the cursor there is fine. Okay. I want to start on this screen showing the raw data, right? Yeah, okay. Okay, here we go. So, time is around 13 and a half minutes in. There we go. We're going to record this for posterity and future introducing people to what the heck I'm doing, right? So, hey there, this is Raimo, and I'm going to give a quick overview of the project I'm working on. It is a general purpose binary format parser. So it's similar to the data dissectors in Wireshark. So for example, if you're looking at all the packets you've captured, down here at the bottom shows you what the raw bytes in those packets are. And you can either click on a byte or a region of bytes, and these data dissectors will kind of interpret what the data means. So in a similar way, for example, here I'm showing an image file in GIF or GIF, however you like to pronounce it, format. And we want our tool to be able to understand this format, be able to pick out different fields of that format, tell us information about it, maybe even allow us to like detect if the file has some corruption in it, or maybe we'd like to tinker with the file format and change some of the pieces of it without having to use a full-blown encoder and decoder. So what my tool allows you to do is describe the format of what you're looking at in a domain-specific language, which allows you to describe the file in two ways. Structurally, So a GIF begins with a header and ends with a trailer and has some data blocks in the middle. And also functionally, as in we're sort of writing a function about how one would parse the bytes to interpret it as a GIF. So you would start at the top and you'd say, well, the GIF starts with a header. So you look to find where header is. And there we see that we have a signature and a version number. And then we have a logical screen after that, et cetera, et cetera. So at the bottom panel here, you kind of see what our goal is, at least for the internal engine of the tool, is that given this data up here, it parses out that the signature is GIF, version is 89A, and the logical screen's width is 300. And it will continue all the way down to the bottom of the file and say that there are 61 GIF data blocks, because it starts with 0 and goes up to 60. And because it starts at 1 and goes to 60. And then finally we have the trailer byte at the very end, and we're complete. So there are 3 parts of this tool, and so far I've finished the first 2 parts. Oh, hold on, let's go back. So I've already written this tool in C and C++ about 5 years ago, up to the point where you see here where we have like a text output of what we parsed. So I wanted to add a user interface to this and some scripting and some other cool stuff. But now that I'm into Rust, I want to go back and port what I had written before to Rust. So far we've ported 2 out of 3 of the major parts of the tool. So those 3 parts are the part that is turning this language, a program in this language, so to speak, into a stream of tokens. So basically identifying what parts. So basically identifying that the first few characters are an identifier, and then we have a brace, and then we have another identifier, and then we have a bunch of other things like a string. Actually, hold on. We need to go back and actually I have to. Let's go back to the part before I flip to that, because I changed this format. It doesn't match. So we're starting over a little bit. We're backing up a little bit. Actually, how far are we going to back up? I'll say this. So there are 3 parts to this tool, and so far I've ported the first 2 parts to Rust. First part being converting the input program, so to speak, into a sequence of tokens for the second part. So these tokens are showing that the first few characters represents an identifier, and then we have a brace, and then we have another identifier, and then we have a semicolon, etc. And basically saying which parts are variable names, which parts are literals, and which parts are reserved words, that kind of thing. So this token stream is packed. So this token stream is passed into the second part of the tool, which takes the token stream and assigns semantic meaning based on some grammar rules. So for example, that the whole file in its entirety is composed of a sequence of formats, and each format has an identifier for its name, some optional arguments, left brace, and then some statements, and then a right brace. So that matches this. And the output of that, sometimes called a parser, is an abstract syntax tree, a data structure in memory, usually a tree form where there's a root. In this case, every format here, like GIF and header and logical screen, would be the root of a tree. And then the child nodes of the tree would be the different parts of those formats, all the way down to the individual leaf nodes, like the statements in there, like that break statement there. So the third part of the tool is going to take this. Hold on, let's back up a little bit. So the third part of the tool, which I haven't ported to Rust yet, is going to take this abstract syntax tree and apply it back to the bytes to produce this output that the C version of the tool makes, which is basically identifying what every byte in the file means. And once we get that done, we'll have parity between the new Rust version and the old C version, and we'll be able to proceed just with the Rust version forward. And what things I have in mind are making it scriptable, giving it a user interface, and possibly even allowing the tool to modify the data so that we can repair files or change files to back up a little bit, to repair files or otherwise to experiment things. Try again. To repair files or otherwise experiment with different formats. This makes a great learning tool and a great analysis tool, hopefully. Something on the order of Wireshark, but more general purpose for any kind of data. So another example of something I might use it for would be, let's say I'm working on a program that like saves its state using binary files. I might want a tool that I can quickly go and like peek into the contents of those files. And since I'd be inventing my own binary format, there'd be nothing out there that would understand it, but I could teach my tool to understand it using my own format description language. So that's basically what I'm working on. And this is going to be done live on Twitch, usually in the mornings, starting around 7 a.m. Pacific time and proceeding until who knows how long this project will go. I try to pick a new project every once in a while. So the previous year we made a keyboard, and I can have a link to that project in the description somewhere. Who knows if we'll be working on this project for how long, what'll be next year, but come join us in this journey of just tinkering around, especially with Rust, because I love Rust. And actually, let's completely delete that last section. I didn't know where I was going with that. So if this looks interesting to you, keep watching. If not, plenty of other Twitch streamers out there won't be offended. All right, so I'll leave that to my future editor self to clean up and cut down. The goal would be to try to fit that within a few minutes, and I think that went for almost 9 minutes. So cutting out the redos, it's probably like 7 minutes long. So that's going to be a tough order, cutting a 7-minute description down to like no more than like 3 minutes, right? Okay, hopefully that's the last time. Actually, it can't be the last time because I have to edit it and produce it and post it and then update the bot command, and then that will be the last time I have to describe what I'm doing, right? Let me catch up with chat. The interesting thing is throughout all of the recap video, unless like I edit that out, everyone's going to see all the chat that you guys wrote while I was recording that. Does the parser get data from the file or an API somewhere? It doesn't actually. Well, hold on. Depends on what we mean by parser. So there are many layers to this thing. So the innermost layer will be getting bytes from an object. So it could be in memory, it could be from a file, it could be from a network card, it could be generated on the fly. I like to make the core of the parser, the tool, very reusable if I can. Now, to test it, I've slapped on a main program that, let's go collapse these and I can show you that. So at the top level, there's like lexer and parser, but I've made these like slapped on these like shells on top of them, like lex and parse. So I don't have the one for the third part of the tool, which would be actually using the abstract syntax tree and actually parsing the data. But just to give you an idea, let's say the lexer, for example, is going to take, it's going to take these bytes, these lines of text, and turn it into a token stream. And so the same question you asked, Worship the Sofa, it applies to this too. Where do we get this program from, right? Is it from a file or is it from an API somewhere? So in the lexer just gets something in memory right here. So in Rust, it's borrowing a slice of a string. So where did that string come from? It doesn't care. The only requirement is that it be in memory, and it's a UTF-8 string or sequence of characters. I did toy around with the idea of maybe we pass in the input in pieces so that you could have the stream potentially not end, but just goes on forever. But decided that for the lexer, it's probably fine to say we'll have the entire program in memory in one long string. So the lex front end to that does read it from a file because that's the most convenient way for me to do it. So we go to the standard fs read to string to get it into memory as a string, and then we let the lexer borrow that string. So it didn't have to come from a file. It could have come from anywhere. And I'm trying to follow the same pattern for all the other pieces. So there's going to be a little shell for each piece so I can test them individually. And then at the end, we'll have I don't know if I'll have an integration test, but I'll at least have some tools that fit all the pieces together. And probably the first one I'll make will, again, read it from a file, but it could also be reused to read it from a stream off of the internet, or it could be that there's an API to feed bytes into it so that you could have one program generate bytes for this one to parse. By keeping the pieces in the library parts of the tool separate and not put too many assumptions into them, then I'm not constrained to a rigid requirement like that it has to come from a file. That's one of the things you learn as you're first picking up programming and design concepts, is a lot of the tutorials you'll read and a lot of the books you'll read and lessons will focus on like saying, well, you're going to open a file and you're going to read the file and you're going to then look at what you read from the file. And if you take that too literally, then you'll lock yourself into this kind of like weakened design philosophy, which says like everything always comes from a file, right? For example. And it's better to like, as soon as you can kind of escape that constraint, to do so, to say, well, I'm gonna solve the problem of handling the data separately from answering the question of where the data come from. So I'll let the thing that gets the data be separate from the thing that uses the data. Now that's very powerful because then you're not locked into having it come from a file. It could come from anywhere. And that notion is called separation of concerns, and it's one of the core principles of great software design. It's what they call an engineering principle, right? So I know I over answered your question. I have the tendency to do that, but I was inspired by your question to point out that yes, I've written a small shell for like the lexer here that does read from a file, but that's so that I could separate the concept of files from the lexer. If I go into the lexer itself, it doesn't care. I have to have some constraints. So the one constraint is it's all in memory at one time. And the other constraint is that it has to be UTF-8 encoded strings. As in, this has to be in UTF-8 encoding. But that's pretty much standard these days. And I figured that having it all in memory at once to fit that is okay because these programs don't get too long. It's not like they're millions and millions of lines long. If we were making a library that was processing a video stream, this would make no sense at all, right? For one thing, video stream is not UTF-8. It's its own format, which has nothing to do with text. It might have text embedded inside, but it's not text, right? The other thing is a stream could last forever. I could go for 24 hours. I could keep the stream going forever, and I'd be constantly generating bytes, and it would be impossible, if not impractical, to put them all in memory at once just so that we could watch the stream, right? That's not how streaming works. A better interface with that would be that instead of passing in all of the input as one slice of bytes, that we would pass in as the input some object which represents the stream, but doesn't have to have it all in memory at once. And then when we, where do we actually do this? Is it in next? That's location tracker, but the Lexer is the same way. It doesn't really matter which one I was looking at, like this input. Yeah, when we, right here, I'm just taking the input that we're given and passing it along to the logos Lexer. But the concept is similar in any kind of library. If we have an API and we have to adapt it to an internal something else that has its own API, as long as both the outer and the inner interfaces are compatible, then if both of them took an object that we can then ask for more bytes, like give me the next few bytes, give me the next few bytes, then where was I going with that? I'm not describing it very well. Right now, we get the whole input at once and we just pass it in. But if we were given something that we could call back and say, give me the next bytes, then I could either pass that to the Lexer as is if it supported that API, or I could adapt the two together. Either way, it wouldn't have to come from, we wouldn't have to have it all at once, right? We'd loosen that restriction at the cost of having it a little bit more complicated. Hopefully the fact that there's been no chat for a long time does not mean that everyone has left, but it means that you're all enthralled by my voice and are just waiting for the next thing for me to say. Yeah, that was a prompt. and you passed. Well, you'll see as I get onto like the next part of this tool that I try to keep things flexible. So whenever I'm designing an API, I'm thinking like, what's the minimum I can get away with as far as dependencies? And if I have any kind of dependencies, I'll try, if they're more than just like this is like, there's probably nothing more simple than I can do than here's the whole program as one string, right? If I had to do something more complicated than that, I would try to abstract it away and use dependency injection. So I would make this be a trait, and I'd make the whole thing generic on that trait so that you could implement the Lexer for any kind of thing that can meet that trait. And the trait would have the requirements that I need. So in this case, the trait would be that it can produce a string that we can then pass through the Lexer, right? But for other parts of the program, it might be, the trait would be like, it has to be able to provide the next byte. And then as long as it can do that, it could be a file, it could be a network interface, it could be an API, whatever you want, right? That keeps things the most flexible. Okay, recorded the intro. I'll come back and with my own recording and post-produce that. So what do I want to do next? I'm like at the crossroads between parts of the program. So last stream I finished the I was gonna say parser, but I kind of don't want to call it the parser, but we are calling it the parser, I guess. So it's bit exact with the C version, which means it produces the exact same output. If I do this and I do like pipe that to like a 1.txt, and then I run the old version in C, and that was this one, and I pipe that to 2.txt, and then I do a diff 1.txt and 2.txt. This should be identical. There's no difference, right? And that parse format was my shell in C for all of the Lexer and parser, basically all of the compiler to turn this into an abstract syntax tree. The fact that I get the same output for the Rust means that we passed the, what do you call it? We're now qualified to go on to the next step. We've passed all the requirements. Give me two good names. Yeah, you said parlexer and parselex, right? I guess I'm just I'm not feeling it right now, but that might just be me. I can call it that until I come up with a better name. You don't know? No, it's your idea. You need to be confident. Yes, those names are awesome, Raimu. You can use either one, and they sound great. I came up with them, and I'm very proud of them. There you go. There you go, Matt Stork. Okay, we don't need these extra shells. I only used them out of convenience while I was recording that bit, right? Actually, what did IDC stand for? I read that as I don't know, but that's IDK. So what was IDC? I don't care? But you do care. It's your work. You should care a lot. Just say, not only do I think these are great, but I feel great that I did it. You do care. Oh, is that what so yeah, the D could be I don't or I do. The ambiguity of acronyms. Or I guess there it's initialism, right? Okay, I think we're starting on a new library at this point, right? Because I have the lexer, I have the parser. So in the C naming, I had called them what? I'd call them parse format, I think. Well, I call it the tool instead of calling it lex. It was lexer, right? Lexer. Actually, let's make a file to represent this. So the C naming and the Rust naming, right? Naming. And we'll even have a little cross there. So in C, it was called formatting. And in the Rust, I called that the lexer. And then I made a shell for that called parse format. And the Rust, that was lex. And then, so no, this isn't right. It wasn't parse format. It actually didn't exist. Not applicable. This thing thinks I'm typing Lua, but I'm not. I'm typing plain text. There we go. Yeah, I didn't have a tool front end for the lexer, did I? Yeah. Parse format was something else. So, right, it was formatting. Oh, shoot. Did I combine the lexer and the parser and not have a front end for the lexer at all? I guess not. So this is also not applicable. Yeah, I'm totally forgetting my terminology here. So it was formatting, and then that was parser, and parse format was parse. So the last part is I have the decomposition. You know what I'm going to do? I'm going to add a little purpose. Well, let's add it to the end. Purpose. This will actually be a good guide that I should save so that if someone asks me what's the difference between a parser and a lexer, I can actually, if they want to know what these words mean, I can pull this up, right? So the purpose of this, turn input program, I need more horizontal space. Turn input program into tokens. Token stream. And this is test the, well, like thin shell around lexer to test it. Parser was to turn token stream into abstract syntax stream. Syntax tree. Wow, my typing is really atrocious today. thin shell around parser to test it. Okay, so we don't have a name yet for this. And this is use abstract syntax tree to parse binary data. And then I think I called it just decompose. Yeah. That's what we've been running to show the whole. It was DataDisintegrator decompose. Yeah. To actually integrate everything together. So I don't have a name for this yet. And this is, again, it's a thin shell around, well, decomposition. Let's say it's a thin shell to test parsing binary data. This is to test building AST, and then that way I can kind of use an abbreviation that the rules when you describe technical terms are you always define the terms. Well, you have to define what it stands for before you define the abbreviation. And I think the best way is to use the full words and then in parentheses use the abbreviation so that we can then use the abbreviation and like you've been told what it means if, the first time it was encountered. Use AST to parse binary data. Thin shell to test building AST. And this is thin shell to test this is going to fit, or I need something smaller. To test obtaining token stream. Okay, there we go. Let's save this somewhere. I think this project deserves like a docs, like documentation. Where's the new folder? But there it is. Folder name, doc. Kind of like SRC for source, DOC for documentation, and we'll call this like terminology, I guess. There we go, terminology. Naming, names and purposes of each, I guess, crate, library, program. Okay. And then this file could also serve as like where I can like define other terms if I had them. You do care about your work. I'm actually curious, how are you dealing with clashes ambiguity on the parser output? I have a similar project which I tried to do something similar, but the ambiguity made me fall back to simpler methods. Do you mean the ambiguity in the grammar? Or do you mean the ambiguity in like the report that you generate or what you identify each byte to mean? If you mean the grammar, okay, let's see what your next statement was. Your problem was the edge cases. It kind of worked, but required constant updates and maintenance. Edge cases are always a problem, especially if when you test, you're only testing the non-edge cases and you leave the edge cases for later. You're just kind of asking for your bugs to hide there. It's kind of like when you clean your kitchen, if you only cleaned the surfaces you can see and you didn't clean inside the cabinets. You know where the cockroaches are going to go, right? They're not going to go in your clean floors. They're going to go into the nice, uncleaned, quiet cupboards that you're not cleaning. So when I think of making tests, I think of making tests not just for the main cases, but for the edge cases. And when I get kind of lazy and I stop testing the edge cases, that's where I'm kind of inviting those bugs in. So for example, I tried to break things in my unit tests here, right? Tests, expression 0. So I have a bunch of positive test cases, right? What you'll get when you try to do different kinds of expressions. But then I also had tried to catch some error conditions, like what if you had a 42 and then you had a bar right after it that didn't belong there? Well, then we say, well, we expect it to catch that as an unrecognized bar token. Actually, that's not correct. Did I not? Oh, I should probably fix that. What it should say is that the second token is wrong, and the location information should have helped us there. Yeah, but this was so it should say the like I should have like second token, or I'm doing 0, 0 because that's I'm kind of self-constrained by the location type, which is line number, column number, but I didn't want to have to like count out characters, and it was sort of beyond the scope of this test anyway, beyond the scope of the thing we're testing. But yeah. Anyway, I try to catch the corner cases in unit tests. If you can, so it's always a good sign when you can write a unit test that has no mocks and you have no dependencies. That should always be your goal. To test early, and test the smallest thing you can. If you can do that, hopefully your edge cases are only applicable to units, and then you can catch them in tests for those units. Now, if you have edge cases that involve integrations of things, fitting pieces together, and then you have edge cases, that's a more difficult problem, and one where you might kind of consider like, is that because the components I'm integrating together, are they not designed to have proper separation of concerns? Because if you're integrating things together and that produces an edge case, that means the integration added something that was not in only one of your components, right? The edge case spanned more than one component. That's a concern that's spanning more than one component. It's not separated very well, right? It gets harder and harder the more mature your project is. At a certain point, you reach the point of where your project is sort of crystallized, and it's rigid, and you can't really change it, and then you kind of have to live with it. So I'm still trying to see, did I you're talking about ambiguity. I'm gonna guess that you meant in the grammar. So for that, like there are a couple of things I can remember that I did have to deal with. One of the immediate things is I'm using Lollipop, right? And it doesn't understand the notion of operator precedence. So for things like the expression was a good one, right? I couldn't make one grammar symbol for expression. I had to have it in what they call tiers. And each tier of the expression grammar represents another level of operator precedence. So the highest tier 11, because we had 12 of them, is the lowest precedence operator, which is the logical OR, right? And then logical and then we had set membership, and then we had inclusive and exclusive OR for logic, bitwise mask, then we have equal and not equal, comparison of, so the comparisons are not equal and not equal, I put it a tier above, and then less than, greater than, less than, equal to, greater than, a tier below. That's just my decision. I could have put them on the same tier. I guess it doesn't really matter. Then we have addition and subtraction, multiplication and division, left shifting, and then at the lowest tier, this is the highest precedence. So the tightest integration between expressional pieces are the unary operators. If you use parentheses and all the things that are non-operators, so map construction, set construction, vector construction, function call, reference, literals. So that's one way I dealt with ambiguity in expressions, is make separate tiers, basically define operator precedence and set up different tiers for each precedence level. And then there are certain ways in Lollipop that you do associativity. So what I learned is a left associative operator is self-recursive on the left-hand side. So if you think about it, if you have A or B or C, it should be A or B first, and then that or C, right? which means that you can't put A or B, or sorry, back a little bit. It means that if it's grouping on the left first and you want to have or in each expression, it has to be the same tier on the left. On the right, it can't be the same tier, otherwise it would be ambiguous. If I made it 11 or 11, then if you just said A or B like this, or C, now it's ambiguous, because is this an expression 11 or is this an expression 11? Which way is it, right? So this is called a non-associative operator, and that is ambiguous. For a non-associative operator, it's ambiguous to say that. It should be a syntax error. So the way we make it a syntax error is or is only in expression level 11, and we use 10 there, so that can't be an expression 11. It has to be a 10, which is one of these. It's a C. That means the one thing on the left has to be A or B. That's the only way that it'll parse. It's non-ambiguous. You have a lot of that? Exactly that type of mind-breaking stuff. Well, so this was a combination of, there was some description in Lollipop's handling where they talk about it. They say we use operator precedence. I don't know if it goes out and says it, but at some point, like the whole point of operator precedence is to solve the ambiguity problem where you have chains of grammar that, like, you don't know how it could be grouped. And here's a nice picture of how you'd express that, right? It could be this way on the left, or it could be this way on the right. Which is it? And operator precedence disambiguates it. Another way to disambiguate it would be to use parentheses, right? So yeah, they described it here, and I'm like, oh, okay, that's how you do it. And then, but they didn't. This tutorial didn't talk about left versus right associativity very well. I had to figure that out on my own. Just by thinking about it, I'm like, yeah, left means we do that first and then that. So the only way it can be unambiguous is the right-hand side can't be an 11. It has to be the next lower tier. And then logically, you can invert that, saying if I put 10 on the left and 11 on the right, it would be a right associative operator, right? It would have to be B or C and then or A in order to make it work. Medimi is rating me with 6 lovely people. And we're just talking about operator precedence, unambiguous grammar, all in the context of making a compiler. I hope you had a great stream, and welcome. Please ask any questions you would like. Just before this, I recorded sort of an intro of what I've been doing in this project, and I plan to make that a video. Because I haven't yet, I can't give you a link to it because it doesn't exist. So unfortunately, there's the disadvantages that I won't be able to kind of go into exactly what I'm doing without repeating myself. And I might do that in a little bit, but this is the last stream. Hopefully I'll be doing that, because it's a lot of repetition if I have to do it. We had some fun with working on a binary search tree. Nice. What's that, Nightshade dude? CBC booty. I'm kind of curious, Nightshade dude. What are the limits these days in Twitch? Like, at what point do you start getting, like, warned about the content of your emotes and your streams? When I see emotes on like that, I'm like, that's kind of like, it's kind of like feeling like if you're a kid and you're trying to find out how far you can push the rules before your parents like and put consequences on you. It's like, what can I get away with here? Like before I get a slap down. See, I was just explaining how, like, I have a domain specific language here. It's described in grammar rules using the lollipop crate in Rust. And why trying to explain how this can be disambiguated, because this could either be interpreted one or two ways, right? Is it A or B or C, or is it A or B or C, right? It doesn't really matter for or in particular, but one thing that it would matter for would be like if it's plus. Actually, I can do this with multi-cursor, right? I can do this a little bit more smartly. thus, and then the ors become times. So yeah, this can mean either that or that, and you actually get different answers, right? So how do we disambiguate a grammar like that? And the way that Lollipop does it is different from the way Bison lets you do it. In Bison, you could define the plus operator first, and then the times operator second, and then that gives you an implied order of precedence. The ones lower on the list are done first. So the answer is that, if I wrote it like that, right? If I flipped them and put them in that order, now it would do that, because it would group the plus first and then the times, right? So we in Lollipop you can't assign operator precedence, so that doesn't exist. So what are we forced to do? It's to make these tiers of grammar where we put the lower order precedences at a higher tier. And it does get confusing, the fact that we order it from lowest to highest. But we have to. I was explaining before like how it works, but essentially like a rule is self-recursive on the left if it's a left associative operator. It's recursive on the right if it's a right associative operator. And if this was like 10 on both sides, now it's non-associative, and you can't chain them like A or B or C, because or only appears in rule 11 and not 10, so you can't form a chain of them. If it was 11 on both sides, now it's ambiguous, because do you put A or B on the left, or do you put B or C on the right? You could do either way. That's called an ambiguous grammar. So making this non-ambiguous by having different precedence levels, avoiding recursive on both ends. If it's not associative, it has to be non-recursive, right? That kind of thing. Didn't we decide RPN would eliminate this entire issue? Yes, that's one way we could do it, but then to do I still have it? No, it's already off of my redo chain. Should I type that again? A plus B times C. So RPN means that we write that as times, A, B plus C times, and then if we wanted it to be that way, it's B, C times A plus. The way you think of it is you go to the innermost parentheses and you push you do left, right, middle. And the middle one does a reduction. And it's like you have a stack. You push B onto the stack, you push C onto the stack, and then times pops two things off the stack and multiplies them and pushes the answer onto the stack, and then push A, and then plus pops two things off of the stack and adds them, right? So push B, push C, then when you see the times, you pop them off, multiply them, and push the result onto the stack, right? And then you'd push the A. And then when you see the plus, you'd pop these two things off the stack and you'd add them. See how that works? Pretty cool. Disadvantages to reverse Polish notation is that that's not natural to read for most people. Most people like to read it like this because that's how they're taught in school. The other disadvantage is that you don't have parentheses at all, so it takes a little bit more thought in advance to do groupings. The advantage is that that's much easier for a computer to deal with because there are only really two things it can do. It can shift something onto the stack, or it can reduce, which is kind of like how these grammar rules work when you think about it. Stack explanation did it for you. There's actually a language out there that is all about reverse Polish notation in stacks. It's called PDF. You might have heard about it. PDF. How would we learn about the PDF? PDF. Oh no, it's not PDF. It's PostScript. I get those two confused. PostScript. PostScript is a reverse Polish notation language. Can we have like a PostScript example? PostScript is like used a lot in the 90s to as a format to print things. But nowadays PDF has taken over what PostScript used to do. PostScript format example. I want to like show you like an example. I wish I could like get better at searches that actually show us examples right away. Here we go. 72, 500, move to. So it moves to 72, 500. Hello world, show. That's PostScript. It's a reverse Polish notation language. So there's a stack and everything revolves around the stack. Every operator is on the right because it operates on one or more things on the stack. Everything is shifted in from left to right. It's very simple, but harder as a human to write or think about unless you get used to reverse Polish notation. Okay, we're talking about ambiguities. Another kind of ambiguity I ran into was if you don't have enough delimitation. So if I were to like remove the parentheses from here, watch what happens when I try to build. Actually, I don't even know how long it'll take to try, but it's going to encounter basically an endless reduction loop where it just can't make an unambiguous parser for this anymore. And the reason is that if expression 11 can stand in for an expression 0, and a 10 can go in for 11, and a 9 can go in for a 10, etc., all the way back down to 0, then you could just be endlessly cycling between 11, 10, 9 down to 0 and back up to 11, 10, 9 and never actually reduce anything. So to disambiguate in those situations requires that you put delimiters. So a lot of the delimiters you see in languages are to avoid ambiguity. So this is a sign that Lollipop is in trouble, and it will eventually tell me that's an ambiguous grammar. So when I'm designing my language, I would add delimiters in any place that otherwise it would make the grammar ambiguous. And here's another way you can think about it. If I wrote you something like, if x no, that's not a good example. What's a better example? How about this? Print x, y plus equals 2. How would you interpret that? One way you could interpret it as print x, y plus equal 2, which means to add 2 to y and then print x and y together. Another way you could interpret it is print x and then y plus equal 2. So we're not printing y at all, right? We're printing x only, and then we're adding 2 to y. And yet another way you can interpret this, which would be really exotic, would be you're printing y, x and y, and then your whatever print returns, you're adding 2 to it and trying to store it back into print. All of these are possible interpretations of this without delimiters. So if you force a delimiter, you kind of disambiguate it that way. it's actually possible to make an ambiguous grammar and then disambiguate it by convention. So then you wouldn't use just your grammar rules. You'd have like a simpler set of rules that are unambiguous, and then like tokens would be allowed to be of certain categories, and then the actual member of the category that's picked, you would make sure that it actually makes sense. That's probably not the best explanation, but like languages like Rust and C++ are like that, where they're not strictly defined with grammar alone. There is a grammar that defines a subset of it, but then to get down to exactly what the meaning is, it uses like a heuristic or conventions like the first match. Like if you have an ambiguity, that means you have two rules that it's one of two rules it can reduce to. You could just say, hey, resolve all ambiguities by picking the first one. First option, right? It's like you're in a maze. Do you turn left or right? You could just always turn left, and for most mazes, you'll get out of the maze. Certain mazes you'll go in circles, but most of them you'll get out, right? Just by making arbitrary decisions when you're faced with an ambiguity can solve the ambiguity. Okay, we talked enough about ambiguities, I think. And I'm driving Lollipop insane because it's going to take forever to reduce that. So let's fix the grammar and build it again. Maybe images. Twitch has to approve them, so I guess it's on them. That's true. We're talking about the emotes, right? Zero room for interpretation error. Okay, I think we had like 3 different contexts that go in there, and that's fine. Okay, get reoriented. What was I doing? I recorded the intro. I went over terminal. Oh, that's right. I need to find names. So I want to avoid using parse here. So I kind of don't even want to have the word parse and parsing for these. How about we say use AST to break to determine. How about to break down binary data into elements? Then shall to test breaking down binary data. There we go. I can just use the term breakdown or breaking down instead of parse, because really that's what we're doing. When I do something like this, we don't have the file anymore. Now we have pieces of the file, and we're doing more than actually just getting the pieces. We're also assigning meaning to them in certain ways. Like we're saying that that's a string, and we're saying that that's a number, right? So it's like use EST to break down binary data into elements and determine their meanings. There we go. Problem is those humans and putting bad data into your stuff with no scheme. Those gosh darn humans. Okay, so if that's the lexer and that's the parser, should I just use the same naming conventions as before, decomposer? The overall project is called DataDisintegrator, so I could call this disintegration and disintegrate. Disintegrate has that connotation of it's like destroying something, though. We're not really destroying it, we're just breaking it apart. Maybe like disassembly? But disassembly is too long. Wireshark used the term dissector, and that's a little bit shorter, but I don't want to steal their term. So, what to call this? What if we call it analyze? And then we can call the term we could call this one that. It's short for an analyze, right? I should call it that because what is Twitch if not a platform for inappropriate puns, right? It reminds me of the ASIMP library, you know? The asset import library. It was designed by, I think, a bunch of folks in Germany, and they picked this for the project name before they realized that this might make people laugh who are familiar with English. So it reminds me of. I'm not too set on this term though, because this kind of makes it sound like the tool does more than I want it to. Really, we're breaking it down and assigning meaning to its elements. But you could do more than that. We could then integrate knowledge about those elements to answer larger scale questions, and this tool wouldn't be able to do that, would it? What if we call it like studier? I could just call it the same, just with I don't want to use the same word because on a file system that is case insensitive, the two folders will clash. Ingest. That's a good one. You can call this digestion. We can call that ingest or digest. I know I took your word and I added a D in front and removed the N, but I don't know which one's better. Ingestion might be better because it really just focuses on the input and not the output, right? So you can ingest the bit stream and then it's sort of in a middle place and it implies that something else has to do something with it, right? Like they're like to study it or to produce something, to poop it out. Makes me think that instead of calling it the data disintegrator, I should have called it the data eater. Data eater. But eat is also just the ingestion part, right? Data eater and pooper. Data pooper. Yeah. I'm terrible with names. I think I like that the best so far, though. It's shorter than that. That's better just simply because it's shorter and it captures the essence of what that is doing. I think that's what we're going to go with. So thank you, Stormzilla. Nom already exists, though. And actually, Nom is not so different from what I'm doing. They've got a pretty cool page with a mascot. Look at that. So its goals are about tools to build safe parsers. Where do they say it? They say it really well down here somewhere. Right here. Designed to properly parse binary data formats from the beginning. So it goes all those examples, which is how I could describe my tool, only the difference being that Nom makes parsers. My tool is a parser because it incorporates a domain-specific language, whereas Nom is like making a Rust parser. So it's slightly different. So this, you'd have to write Rust code for every format. On mine, you just write a description in a DSL. But yeah, we can't use nom, no matter how much we like their cute avatar mascot, because that already exists and they have the copyright. We call it nom nom. Nom nom. Is there a crate called nom nom? Or is that too close to nom? Are you allowed to like take the name of a crate and just like say the word twice? Oh, look, someone did it. Intake nom 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 nom. What the heck? This looks like it's someone's joke project. Omnom. Streaming parser extensions for buff read. I could call it and we could just remember that there should be an N in front. It'd be really cool if we could find something that OM stands for, and then it's like, yeah, we're calling it because stands for whatever. And then we can remember, like, the secret inner joke would be that it actually is extracted from nom. Like, nom is the object manipulator, or object, yeah. When really it's nom. Okay, so we need to make our foundational library ingestion. Let's do it. So cargo toml ingestion. Make a directory called ingestion, which has a cargo toml. Okay. For some reason, the muscle memory for using this keyboard, which uses, and now the word's escaping me for the kind of layout that I have. More coffee is needed. How come I'm not able right now to remember what kind of keyboard layout I have? It's something mod, it's Colmac mod DH. So I'm typing with Colmac mod DH right now. And my index finger keys are getting screwed up. Why is that? Do you have a nice picture here somewhere? There we go. I'm using this layout, and I keep hitting, like, I'm getting M and J confused, and I'm getting D and some of those are keys confused. And what is this? I'm using this layout. Maybe just need to slow down. No, it's my custom keyboard. Not only did I make my own keyboard, but I also switched to Colmac layout. Let's do the keyboard command. That was last year's project. Okay, so rather than typing this, I'm going to steal it from somewhere else. But we just go to the Lexer, doesn't really matter. Copy, paste. We're not using, actually, what I would like to do is go to parse and use that dependency list, except for anyhow, and clap. We want these, and maybe even that one. I should just assume I might need my utilities library, right? Okay, can you restart? Probably because I don't have a source with a lib.rs in it, right? Which should have a configuration test mod tests, use superstar, and then we'll have like a placeholder test. Placeholder. Actually, we're going to assert falsehood. Okay, what do I have to do to make Rust Analyzer happy? Do I need to restart it? No, there's something else I am doing wrong. Cargo build. Oh, I didn't see that. Yeah, that needs to be ingestion. That was it. Okay. So the unit test should be testing the most elementary things I want to do in this library. So I'm thinking that this library shouldn't be shouldn't be doing the parsing. It should just be given the abstract syntax trees. So we want to just feed in. Oh, that actually makes me think the abstract syntax trees should be its own crate, not in parser. This really shouldn't depend on lexer and parser at all, should it? Also, the parser shouldn't depend on the lexer. The parser should just depend on the token type. But then that's the problem with there is that the token type is inextricably bound to the lexer now because we do a derived macro for logos around it. So that was a choice, a design time, which binds the token type to logos. So that really shouldn't be removed from the lexer, but the parser doesn't really need to depend on the lexer, right? Maybe I should remove that dependency right now. I think I should. So let's do that. Let's fix the dependency of parser on lexer. So we shouldn't have that. I think what I'll do, actually, what I think I remember this Lollipop tutorial doing. They right away put their AST into an AST library at some point. Maybe not right away. Yet I still don't like their tutorial. Yeah, they have an AST to RS module to put this in. I should have done that when I saw that. That should have reminded me that we should do that because separate the concerns out. Let's do it right now. AST, the abstract syntax tree. Okay, so then and then for yeah, even in dev dependencies, we shouldn't care about the lexer at that point, right? The parse will depend on it though. So in parse, we depend on the lexer and the parser. But parser doesn't depend on lexer. Does that mean should parse depend on AST also? I think the answer is yes, because we're going to do more than get it back from the parser. Okay, let's do that. So cargo toml has AST, and we have an AST folder which has a cargo toml which has a lib source directory. Again, I typed an E instead of an R because I know what's happening. The QWERTY muscle memory and the Colmac muscle memory are clashing. That we're done with. Here we're going to copy and paste and name this AST. It shouldn't depend on anything. should have no dependencies. Absolutely none. That's a Leaf project. Okay, in there we're going to move all of the types that were in the abstract syntax tree. So that was in parser. Source. Yeah, these things. Conditional, expression. So move conditional, move expression, move key. How do I do this? Control. Key value, move operators, reference, and statement. Actually, not key value is special, right? Oh, no, it's not. It's just a struct with a key and a value in it. But that's temporary, right? Hold on. Let me see where key value is used. Find all references. Oh, we do have it in expression. Okay, then it goes with it then. So conditional, expression, format, key. Actually, all of these go, right? Yep. Because the parser the only thing it really does is it wraps lollipop. So these all move into AST. Move. Okay, and then parsers, cargo, parsers, lib. All of these modules move to this one. Okay, and then let's see where it breaks. Okay, so we do use utilities to implement the display trait. So we do want dependencies on utility. And that was pretty clean. What's the problem here? Never constructed. It should be constructed. Why does it say it's never constructed? Wait, what? Statement has a derived impl for the trait debug, but this is intentionally ignored during dead code analysis. I thought because it was public, it's not dead code. Do I have to name the part public? You can't do that, right? You can't name a variant public. So why does it say it's dead code? Oh, I know why. Because we don't do a pub mod here. Hold on. Try to remember the key sequence for this. Was it this? Yes. If I do that now, it's not going to think it's dead code. Yep, that's it. Okay, so then AST should build. Cargo build lib AST. Is it project AST? How come I can't remember this? Package, or P for short. There we go. All right, cool. That was easy. Extracting it out into another library, piece of cake. So this shouldn't affect the lexer at all. And lex should be fine. The parser is going to be broken though. Okay, so we have to fix that. Okay, I mean, that's still true. What's wrong with that? Oh, wait, did I remove that dependency? Yeah, we can't, the parser does depend on Lexer for the token type. Yeah, there's no avoiding that. Lexer. Um, okay. Yeah. That parser depends on Lexer for the token and error types. And I can't avoid that, right? Yeah. Okay. Unless I have to be able to I'd have to be able to sever the token type out of Lexer, and that's hard to do because of how this is defined in token. The fact that we derive from logos, which is a Lexer implementation detail. Actually, I can think of one way to do it. We would have two different token types, and we'd have an adapter between them. So we would have a generic token type off on its own somewhere in another library. The parser would use that, and the Lexer would turn these tokens into the generic tokens, I suppose, by just stripping off this information, just doing a copy from one to the other, right? I guess it wouldn't be too bad. Let me put that as a to-do item to consider. Consider separating token to two types. One which contains the Lexer, the logos implementation, and the other to be consumed, to be used by the parser. By parser. Okay, I did it. So for now, we the parser does depend on the Lexer. So in the future, if I were to do that to-do item, it would depend on not Lexer directly, but it would depend on like token. There'd be like a token library. Because all we really want from the Lexer in these tests are use the token type and the error type for token. Actually, where do I use that error type? If I comment that out, what breaks? Actually, a lot of things are going to break. Let me fix the things that are broken, and then I can see why do we use token. Okay, yeah, these are coming from AST, so we don't need to pub them anymore, and we have to do AST in front. Okay, I guess we don't use statement. We just use format. All right, tests. Probably a similar thing. Yeah, all of these things are AST things now, right? So that's a sign that I'm actually doing a good job in separation because we should minimize the number of crate imports. And these should all be like cleanly separated into their own library if possible, right? Yeah, I think location should go with token also if we were to separate the logos from non-logos parts of the Lexer. Okay, unfortunately, I'm gonna have to do that like 20 times, but that's okay. All for a good cause. Maybe I'll put this in my clipboard. I bet this will get faster the further I get. Okay. I keep forgetting that if you're on a line, you can hit copy or cut, and it'll do the whole line, which is what you kind of want to do here for fast development, right? Copy, paste. There we go. Need to spend more time learning how to be a more efficient developer. So like fewer keystrokes, right? And less use of the mouse. Like right now I'm using the mouse to go down here and select. If I could just memorize the key combination VS Code to go to the next file, or to go to that pane and then arrow down and enter, I think I should spend time doing that. I used to do that when I was younger, but at some point I think I got lazy and I decided, oh, I don't need to do that. I can just not think about it, and then I just started slowing down. If I like I'm seeing right now when I use the whole line cut and paste, it's actually so much faster to fix that stuff, right? It's worth it. Why am I not training myself to do that, right? That and the auto formatting is like saving me a bunch. Control X is very good when you learn how to use it. Yeah, actually, you know what? It's not even Control X for me. It's middle left shift and then um, index finger top key. So what is that on? I closed it. Let's look history. Colmac DH. So I'm doing, imagine 3 shift keys on the left and 3 shift keys on the right that I'm using my thumbs for. So I'm doing middle shift Y. That's cut for me. Copy is U. Yeah, left shift U. I have to think about it because I put it into my muscle memory and then I stopped consciously thinking about it. Yeah, copy is middle shift U, and middle shift L is paste. I just arranged it so it's paste, copy, cut, and then that's left. What is that? I think that's begin, and then that's home, left, right, end, or something like that. I see people doing VS Code is you just use that global bar to switch files. You don't really do multi-tab navigation. Yeah, well, without the bar, I can't really see what's broken, right? This doesn't highlight in red which files have errors in them. I guess I could use this. So if I use this, maybe I can go faster. I can just, I know I'm going to need this line, so I go there and like just go to the next error. Yep, that works. And then paste, cut, paste, copy, paste, copy. Go to the next error. Yeah, that works. So that's paste, cut, paste, copy, paste, save, copy. Actually, that didn't copy what I wanted. It's going to paste like this, which I really want that. Anyway, cut, paste, copy, paste, save. Oh, format goes with AST. So what's the key combination to go to next error? I guess we can look that up. I should just spend time to do this, right? I should look at what are my key binds. It's not, it's like key mappings, right? Oh, I actually need the command palette. This one, keyboard shortcuts, that's it. So I want to like look for next error or something. Next problem, it's Alt F8. That's really hard for me to type. So I should probably try to bind that to something else, right? So if I like close this window, Alt F8 would be that. I didn't even hit it right. I don't know what that did. I'm not even hitting it correctly. That's F8. That worked, kind of. But it also opened this window. How do I get rid of it? If I hit escape, okay. Alt F8 does it? I don't think I can hit Alt F8 on this keyboard because for me to do function key, it's hold down right middle shift and tap on H or whatever that key is. Yeah, H. And then on the number pad here, 1, 2, 3, 4, 5, 6, 7, 8, 9, hit the F. So if it's F8, it would be F. So it's like right middle shift H, release, and then hit F. But then when do I hold down Alt, which is holding down I? Yeah, it's like control, Alt, Command, and Shift. Actually, maybe it's O instead of I. See, I dug my own grave making my own keyboard and switching to Colmac, and I have only 36 keys. Well, at least F8 works. Maybe I just use that. Paste, cut, paste, copy, paste, copy, save, F8, escape. Okay, that's a little bit better. So now we're getting more efficient by remembering that F8 goes to next error. Copy, save, F8, escape, paste, cut, paste. I don't know why, like, I need to consciously train myself to do this. Shouldn't I be smart enough to, like, decide to learn these hotkeys? Escape. Escape is left, like tapping first left shift. It's a mess. Paste, copy, paste, copy, save. F8, escape. Cut, paste. Actually, I wanted this one. Cut, paste, copy, save. Oh, I got that backwards, didn't I? It's grammar that goes into create. Copy, paste, copy, save. The grammar goes with the crate. This is making it faster, which I need to remind myself. It makes me faster. I will, even though it's painful to do, I will be happy that I did it. Right? Heat. Paste. Grammar goes in there. Copy. Paste. Copy. Save. We're out of errors. That was it. Look at that. Oh, no, we still have errors. How come it didn't show up as errors here? How come it says no problems? Do I need to like restart the server to see those errors? I think I did need to restart the server. No, it still says that there are no warnings. Is it? Oh, it's in tests. That's what it is. No, but I had fixed that. So where are these errors then? Oh, they're in the generated grammar. Those are not included. Dang it. Okay, well, we can just search for crate. Oh, I know where that is. It's in grammar. Yeah, this is not a Rust file, so Rust Analyzer doesn't look at it. We have to fix this. Well, one problem is I shouldn't have had use crate instead of all in front of all these lines, right? Shouldn't it just be use AST, and then we can do that. And then for all of these lines, pick all semicolons down to here, and then do a comma, and then all use crates down to here, go away, and then end, comma. And then all of these get indented. That wasn't too bad. I should do the same thing for Lexer, right? The use Lexers go away, indent. All those three turn into commas. End with that. Expected token, comma. Oh, these are wrong. These are semicolons. Yeah, I need to minimize my use of the mouse. F keys are just insane to reach for you. Yeah, so that's why for me it's like a quick tap of thumb and index finger on the right, and then the next key is I hit the next key as if it's a number layer, and then that's the F number layer. Thing is, I can't hold down an F key, and I can't modify an F key right now the way I've done it. So I can never hit an Alt F key, which might be a good thing because I can't accidentally hit Alt F4. Parser statement. Wait, in the main? How come that didn't show up as an error? Now it does. Okay. Yeah, that's that. Actually, I wonder if I should promote these up into the top level AST so that I don't have to do AST statement. That'd probably be a good thing, right? Yeah, these I kind of just want to like suppress the warnings here for now. Well, I could just not do that until I need to. And this, I don't need to do that. Now I have no warnings, no errors. That's an unfortunate misspelling, wasn't it? Oh, I have a place where I have key, value. Oh, look at that. That should just be key value. See if I have any more suggestions from Clippy. Did you also switch the key layout on your smartphone for consistency? No. So, you know what I've learned is that it's possible to have multiple muscle memory sets and they don't clash too often. What you have to do is there has to be something different about it. So for me, it's this particular keyboard. I'm okay with doing Colmac, and I would probably have a really hard time doing QWERTY on it or the smartphone layout on this. But on the smartphone, I have a fine time doing the QWERTY and the numbers, even though the numbers are flipped upside down from a traditional keyboard's numpad or the 36 key keyboard. And I think it's because when I'm typing on the smartphone, the context is different. It's a smartphone context, and my brain says, okay, of all the typing contexts that I've learned for muscle memory, pick the smartphone one for right now. And if I'm on this keyboard, it's like my brain is saying, okay, engage the Colmac muscle memory. So yeah, I think I would have a problem if I wanted to have two different layouts on the same keyboard and switch between them. That would be a real hard thing. But the context alone seems to help me like keep them separate, and they don't need to be consistent with each other. All right. Yeah, I think for AST, one final thing to do there would be to do a re-export of the things that we care about, right? Because it doesn't really matter. It doesn't make sense for a library to re-export all of its sub-library as is, because it exposes the internal organization of things, right? So we should just re-export. So pub use conditional. I think this is the best because it's not exposing internal details. That was a choice I made to have them be separate. Maybe I should separate those two into separate modules. Because that's the only oh no, here's another example where I had to have two types, right? All the other ones are just one type. Okay, now that I do that, I'll have errors, right? So this, I think, rather than having to do this over and over again, I think we can do search replace. Where's the replace? This one right here, right? And I want to exclude the AST as well. So let's make sure it does all the right things. Okay, we want to exclude, what folder is that? The target folder. That looks good. So do it. How do I do it? That one? That button. Replace. And then we'll do the same thing with key value. What's the key acceleration for that? Control Alt Enter. Control Alt Enter. Next. There. So how do I select multiple things? Oh, I'm just hitting the wrong key is what I'm doing. There. Control Alt Enter. Enter. This one's trickier because it's multi-line. File save all, right? Oh, I don't need to save all. They're all saved automatically. F8 from here. Format. Tab. There we go. Control Alt Enter, Enter. How do I get to other tabs with the keyboard here? That's not it. I don't know how. What's the keyboard shortcut for it? Switch tabs, panels, panel. It's called a panel, right? Panel left. How do I? There's no keyboard for it. Oh, that's switching down here. How do I go between these things? Gosh, I don't know. It's one of these, but I don't know what it is. Some things we have to use the mouse for until we figure them out. You can't go from the code panel into the left pane. You can only close the controller or something. You can't, huh? Actually, this is the one we want to change, right? Maybe I should switch to Vim, right? Force myself to use the keyboard for everything. Mouse is just slow. Keyboard's so much faster. Statement. I think if I try to minimize the amount of use of the mouse, that'll help me like... Okay, that's the wrong keyboard combination. It'll help me like get faster because I'll have more practice with the keyboard shortcuts. Like Alt Control Alt Enter to hit this button rather than actually mousing over and hitting it. It's your main gripe with VS Code and you work a lot. Yeah, well, almost everything is bindable, right? Maybe we can look for it here. We can say like, it's just, what are these things called? Are these called panels? That's the problem I have, is I don't know what term it is, because it could be one of these things that doesn't have a key binding yet, or we could add one. Like maybe it's one of these, workbench, panel, like who knows, right? It could be one of these. None of them seem right though, right? Next panel, so it's not this, maybe next panel view. No, that was the closest one. That was only affecting what we saw down here, right? Next panel view, and it like just circulates between these, and it's not even mapped to anything. Is that work up here? So it's like it thinks this is the panel. So there's no name for this unless it's maybe editor. Editor. Like there should be a way to go between the next editor tab, right? Tab, maybe. Focus terminal tabs view. Huh. Tab key moves focus. I wonder if that's what it is. Like the focus on which area of the editor? Control M. Control M. Then I hit tab, and what does it do? I don't know where it's going. Oh, it's going down into here now. And now I'm stuck. Yeah, I don't fully understand what that's doing. Close that panel, gonna do next panel, I'm gonna see if it works. So it's like this, and we do. It actually doesn't seem to do anything. Probably because it's closed. Actually, I don't need to hit that, right? I can do F8 and then is there a shortcut for hitting that one? Alt F8. I can't do Alt keys though. Wait, how come now it's down to one problem? Just to F8 again. Conditional. I'm here to code and drink coffee, and I'm all out of coffee. Just like to say that. Okay, so I think we'll just fix these up manually. So if I just delete that line and this line, it should do it, right? Yeah, and then we'll just hit all these other files the same way. Cut, save. This one is just delete that. Cut. Oh, I did a page down by accident instead of a line down. Cut, save. Cut. No, don't do page down, do line down, save. Cut, line down, cut, save. Is that it? Nope. That the grammar has to be fixed up here. Cut. No, not. I keep hitting page down. That's so frustrating. I wonder why. Well, part of my muscle memory wants me to like page down instead of line down. I wonder what. This space I happens if I don't pause long enough between pressing down the I key and releasing it. It thinks that if I release the left shift too quickly after or before releasing the I, then it thinks it's a space I instead of a up arrow, up and down arrow, or I and E. Up arrow, down arrow. Okay, we did it, chat. Close all the editors. So AST is now nice and refactored. And what's this? Original diagnostic. Oh, it didn't clear out the diagnostics from that auto-generated file. Let's see how long this file is. Are we up to 1,000,000 lines? Oh no, we're only at 149,000 lines. This is what is generated from our grammar file, by the way. From this lollipop file, it actually generates 149,202 line Rust file, which is the generated Rust from our grammar. There's a command there. It comes unassigned, apparently. How can I navigate between recently used editors without a picker? Workbench action open next recently used editor. Let's see if that works. Open, no, it's basically open next. It's not doing anything. Maybe in group. Oh, that works. And I have that bound to Control K, Control Page down. Wow, that's really awkward. Control K, Control Page down would be this. That's really awkward for me to type. But it's doing it. It's cycling through. I totally need to rebound that. That's like begging to be rebound. Thing is, I would need to sit down and think of like, what would I want to bind that to? And what isn't, well, how would I want to bind that? Maybe Alt Tab? Can I bind Alt Tab? Because I'm not using Alt Tab for anything. What if I bind Alt Tab to it? Key shortcuts. Open next in group. Yeah, this one. Let's rebind that one to Alt. Oh, that's Control? Oh, and I can't bind that. That's Alt. So I can't do control tab because I guess my VM is capturing that. How about control left and right? They all have existing bindings. What are the bindings for control left? Breadcrumbs focus previous. Get lens. I don't know what that means. List collapse all. So if I'm out here and I do control, it doesn't do anything. So maybe it's safe to bind. Yeah, let's do that. So let's go. Can I go back from here? Can't. But I can do this again. I just have to type here. This is painful. This one. Bind to next, it would be right? So enter, and is there an open previous? Previous editor in group, bind it to control left. So I have control left and control right. Let's see how that works. Control left, control right. Actually, that's not too bad. Look at that. I just need to now think control left and right. They're making my editor better. Not you did by closing the terminal control tick mark. So for me, it's a Command J. Command J opens that terminal. The code pane is the bottom. So yeah, what is that key that I'm doing? Toggle panel visibility is what I'm doing. To close the terminal, I'm doing toggle panel visibility. So I don't know what control, I guess we can type control tick mark. What does that do? Toggle terminal. Should I be doing that? Is that better than this key? Probably because if I'm on output, I should, oh, that's nice. So I should be doing that rather than control J, or rather than whatever this is. Toggle panel visibility. So toggle terminal is more specific to terminal. Control tick mark instead of meta J. Yeah, we're learning to be better at VS Code. I just think it's time for me to stop avoiding these things and like learn them while I'm doing it. Okay, so back to what Vicent did. Close the terminal J and then close the side menu with B, right? So then close, well, I can't do it while I'm typing in there, but yeah. I'll close the editor and then control B. Oh. Okay, anyway, I like my control left, except for we have to, that window's tricksy because that window captures all my key presses. I like this binding. Control arrow is going to go between editors now. Because it didn't before, it didn't do anything. And alt left goes words over. Control home and end go to the top and bottom. Oh, wait, what is this? Page down and page up are doing the same thing? Wait a minute. Oh, look at that. It's already bound to that. Oh, that's different. So there's open next editor and group, and then there's open next editor, which is already bound. So maybe that's what I should be doing. Could be doing a control page up, control page down. So maybe I ought to bind to clear that binding. How do I like, if I get to that, can I get, I have to actually type in open previous error to see all the bindings? Or do I just delete the binding? Yeah, just delete the binding. Delete binding. Okay, so it was already bound to control page up and page down. Yeah. All right, getting too distracted. We're good. Everything builds. The abstract syntax tree is nice and refactored. Has a nice interface. There should be nothing in here that relies on anything other than my own utilities and the standard library. Actually, I don't even need to do that anymore, right? Yeah, can't I abbreviate that? I can, and I will. Yeah, that's much better. Why be so redundant? So here I can do a trick where I just select those and then I have multi-cursor, go to the beginning of the previous word, hit enter. Slick. Okay, we're done with AST. Lexer, I'm just going to do a quick scan of this. Yeah, we're still including the token type, and that is bound to logos. Yep. I punted on splitting that out. Okay, that's good. And then parser. This is the one I'd rather not have. Actually, why are we depending on lexer here? Because parse takes a lexer? It shouldn't, though. Why did I do that? This shouldn't be here. It should, because this thing can take any iterator of, yeah, we can sever this. I don't need to say that. It can take anything that can produce tokens, right? So instead of lexer, it should be lexer token. And then here it should be generic on some t, which is into iterator item equals token. And the lexer is t. I don't like using t though. What should it be? Tokens or into tokens? Into token iterator? I like to use full names here because when I read it later, I'll know what that means. See? Still works. Except for I have an error on some line. Oh, right here. Another bracket. There we go. Wait, there's an error? To triple is not, oh, right. It has to go into this thing. The trait bound lexer token to triple. Yeah, it's this type here. Yeah, I think this has to be the full thing, right? Result. It has to be whatever this lexer implements. Oh, and that's, I think I have, there's no way to avoid it, right? I have to put something there. Can I have like, how about we do this? Parser input. And then into parser input. Iterator. And then we'll just have this out here where that goes there, that goes there, and then I get to put here parser input. And then we separately describe what parser input is. That's a result. Oh wait, I can't use a concrete type here. I have to use a a trait. Well, then we only have one generic type. I have to put it here. That's the only way to do it, right? So that's result. I think it's location. Token, location. I think that's what it is. And then the type is error. But we have to import those now from the lexer. There we go. So now it's not bound, oh, it is still a problem. I'm trying to get it not bound to the actual lexer itself, but just to the token and the error types, because those I plan to eventually remove from the lexer completely. So what's different there? The error type. One is error and the other one's lexer error. So what's this error type? Oh, that error type is standard error. No, it's not. Where is the error? Oh, this struct error. So I have to be specific. Lexer error. Try Control Plus when the yellow light bulb appears. There are refactoring helpers. For me, it's Command dot. What do I have Control Plus? Yeah, I unmapped Control Plus. It is Command dot or meta dot quick fix, right? Yeah, I have it mapped to command. That's the problem with these keyboard shortcuts. Everyone can remap to anything else. So when you tell someone to try Control Plus, what we really want to say is try whatever you have bound to quick fix. And then I'll look it up in my own keyboard shortcuts. Because chances are I probably rebound it with my wacky keyboard. Okay, we have an error. Required by a bound on parse there. Type mismatch, resolving lexer. Expected result, lexer location, blah, 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 found tuple. Oh, I'm not required to return an error? Huh. Actually, does my lexer return an error? It doesn't. What am I doing with errors then? I'm reducing them to illegals. Huh, okay. So yeah, then I have to fix that then. It's not result, it's just that. Huh. That makes sense to me because we have a special error token in there. But then right, errors are represented by a special token now. Is there a quick fix alternative for NeoVim? I would hope so. Quick fix is like super useful. Okay, I'm happy that I did that step because that clears the way for eventually token and location shouldn't come from the lexer. In fact, maybe I should just make the leap now, right? This to-do list item that I had. Consider separating token, one that has the logos. I guess that's locus dependency. and the other to be used by parser, because we don't want the parser to depend on logos. I want to separate that because maybe someday I want to have an alternative lexer that doesn't use logos, and I don't want to have to change my parser, right? Maybe I do that now. So make this depend on like token location and token. I'm really, really tempted to do that. Another reason to do that is because I have, it's really that there's not a good separation of concerns again between logos and the parser. And it's evident if you look at the token, it has some extra enums down here that are not they're not bound by attributes with logos, because this has nothing to do with the lexer. This is post lexer. So right, in the logos enum, you wouldn't see these at all. Yeah, I think that's what I want to do. Actually, where do we use bad string right now? Let me make sure of that. Yeah, so we only use it in the wrapper that I made. That if we get a right, it's taking the error and turning it into a token. That's exactly right, because I didn't want to perpetuate the lexer's error type at all. Where does that error bad string come from? It comes from there. Yep. Right. Okay, so I know what I want to do then. I definitely want to extract out the two kinds of tokens. There's the token that logos knows, and there's the token that the parser knows. There's going to be some repetition because some of these have to map one to one, but others will not map to one, right? Like, yeah, these two are not one to one. Okay, let's do it. I've convinced myself. Close everything. Go to cargo toml. We're going to invent something new called token. So we need a directory called token. And in that directory, we want a cargo.toml. And we want a folder called source. And in that folder, we want a lib.rs. And we want, here's an opportunity to separate token from location because they really are different, right? So we'll have token.rs and we'll have location.rs. And in the lib, we'll say mod token, mod location, use pub token, and use pub location. All right, and then I got to start to take stuff out of the lexer and put it into token. But first, don't I need to update this token? I did that. Just click this to rerun it, maybe? No, I need the cargo toml to have something in it. Okay. Let's copy from lexer's cargo toml. Let's try that key sequence I learned. There we go, that worked. Look at that. That was much faster than using the mouse. We don't depend on logos. That's the key thing, right? And we're not going to depend on test case because that was all logo stuff. So this should be a data only library, right? For now, a data only library. So no dev dependencies. Now I can click that, right? Nope, still unhappy. Failed to load workspace member token caused by couldn't parse the manifest. Oh, I put that in the wrong file. I need to go to the cargo toml in token there. I think I accidentally just made this text smaller. How did I do that? Oh, it's that key. Interesting. Can make it really big, or I can make it really small. That's the right size, right? Okay, so lexer. Yeah, let's take all of the stuff out, the location stuff first. Where to put that? I think that was in lib actually here. Here it is. There's this like struct location, and then there's like a from string location, and then location tracker is more to do with the lexer, right? It's not used anywhere else. So we're gonna just leave that there and cut that part out and go over to location and hit a paste there. Okay. Okay, and then I think I'll start by duplicating the token from lexer. So just copy all of that and then go to tokens token and pasting this key, right? Yeah, okay. And then on purpose, we're not using logos here. And also this is all from the lexer. We don't want that. We don't want any of that. We just want this, and we're deriving, what are we deriving here? I really don't like clone for token. So let's see if we can get away without it. And then debug's fine. I'm looking at the wrong one. No clone, no logos, partial equals fine. And we don't have these. Just strip out all of the token attributes. They're gone. Okay. And then do I keep the comments? Maybe. Okay, all the regexes go away. Why did I repeat myself there? Oh, because I had different regexes. Literal in binary, octal. Actually, there's a way to quickly do that, right? It's just select all of this 3 times, delete, and then back it up, hit a comma. And there we go. Look at that. Alt left arrow for you. That goes back a word. For me, I remapped meta control left to go back to the last context. Doesn't always work though. Okay, symbols. All these blank lines that I probably should have cleaned up the earlier when I had multi-cursor. Literal strings. Yes, so this is what I want the parser to see, only this, right? And it's not dependent on anything other than built-in types like string, F64, I64, string. So it's pure. Pure token, and then a pure location should just be line number, column number. And actually, we're probably going to abbreviate that to line and column. What kind of data am I parsing? If you were here 2.5 hours ago, you could have seen the actual raw recording of the soon-to-be intro video for this project. Since you missed that, let me give you a really, really boiled down answer, and I'll try to answer it top down. So the kind of data I'm parsing is any kind of data I want. So what kind of data do I want? One example of that would be image files. Let's say I'm interested in learning how image files are structured. So what I could do is write this, and I am working on a tool that can compile this into an abstract syntax tree that it can then walk in order along with the raw bytes of some file, like this GIF file, and make sense of the individual bytes in it, like this. So it can say, oh, look, actually I can put that side to side for even more dramatic effect. The first 3 bytes is GIF because the GIF begins with a header, which begins with a signature, which is a string, which is 24 bits long. If it's not GIF, we would have stopped with an error. The next 24 bits is a string called version, and it has to be 87A or 89A, otherwise it's an error. And then we're going to return the version for the value of the overall header. And then we're going to parse a logical screen, and that has a descriptor, and that descriptor has a width, which is a little endian unsigned integer 16, which is that we read 8 bits, low and least and most significant, and then we assemble them correctly. That's what this does. So that's essentially what I'm doing. Now, once I got this running in C 5 years ago, I kind of put it on hold. Now I'm revisiting it and porting it to Rust because I am doing that for fun. Once I get this up to where it was in the C version, which is like a command line tool, I think what I want to do after that is make a nice scripting integration and a nice user interface for it so that I can do stuff similar to what Wireshark does with protocols. So they have these things called data dissectors. You can capture some packets, click on a packet, and it shows you the bytes. And if you click on an area of the bytes, it interprets it for you. I think it would be neat to play around with protocols and other file formats using a really, really extendable UI framework based off of my own engine, where I can describe the format using a language that's similar to C, structs and functions put together, right? This is structural. It starts with a header and ends with a trailer, but it's also functional in that you can have loops and you can have conditionals. So the way those are melded together is the parsing of these bytes is an in-order execution of statements that turns into an in-order construction of what the data means. So other kinds of data I'd like to parse: WebSocket packets, movie files, stream formats. Those all sound fun to me. And yeah, all the stuff I do on my Twitch channel here is for fun, and a lot of it's Rust based because I'm really into that. It can't be open source because I haven't written this command yet, but I have job rules, and my bot doesn't know it yet. You know, no better time than now to do this. Let's make what job rules is. Add com job rules. Raimu is allowed. Well, Raimu has a job, as a day job, that is okay with him streaming as long as, let's turn on wrapping for this. As long as, 1, it doesn't involve games. 2, he doesn't mention work. And 3, he does not participate in open source projects. Okay, there we go. We're gonna add that command. So I can elaborate. They're not okay with me participating in open source projects because they have a conflict of interest procedure I would have to go through for every single contribution in open source, and that's practically impossible for you're right. It's not that it can't. I need to elaborate on this. So we're going to edit that. Edit com. It doesn't involve game development. There we go. Thank you for helping correct that. Why would a job not be okay with you participating in open source? Because then here's one reason. If I were to make an open source contribution and it was of low quality, let's say, right, poor quality, or it affects my reputation, gives me a bad reputation, and then someone figures out that I work for said company, they can then say, oh, well, here's an example of an engineer at that company. Look how bad their code is. Oh, so even open source projects unrelated to vertical? Yeah. They do not want to be associated with my hobbies, right? So that's why I can't mention work, because that would be tying my work to my hobbies. They don't want that. The open source is a reputational thing, and the game development, they see it as a clear conflict of interest. So it's all of these can be superseded if I have written permission exception, like an exception in writing. But the procedure to get an exception in writing is so difficult that I'm not willing to go through it. So I'm just steering. Why does it keep? I can't close this. I want to close it. The close button is inaccessible. How about I just go to here and close it from here? Yeah, there's a procedure to get an exception, but it's too hard to do. Control W, that's true. That would have worked. I got to try to remember my keyboard shortcuts. I think the cat wants out of the office. Hold on a sec. Before I let the cat out of the office, we're going to have the cat say hello to you guys. Okay, bye-bye, cat. I know, he's adorable. She's adorable. My last cat was a he. My new cat is a she. I say he sometimes. It's embarrassing. Oh, this is like pub use, right? There we go. I fixed it. So if you had a second channel that you not use your real name, mock the email and video cam, I kind of think it's unethical, because it's more like hiding that I'm doing something wrong. And I'm one of those people that's like super into following rules, like more than most people. So I wouldn't be okay with that. So on the one hand, I could probably do it and no one would care and I'd get away with it. But on the other hand, I wouldn't be okay with the ethical part of that. Sounds like an old 90s mega corporate management mindset. Reminds you of a few places you used to work. Yeah, so it is what it is. If I don't like it, I don't need to work there. Right? And so what I like getting paid. I like the work. So the balance is I set up an arrangement where both myself and them are happy. And then there's just some constraints. There's plenty I can do on stream that they'd be okay with. But yeah, that question comes up, so I felt like I needed to make a command. Because if anything, number 3 is what people are always interested in. Is this open source? What's my GitHub? All of that. If I ever, if the situation at work changes, then I would check this into GitHub if I was allowed to. Why it doesn't allow open source? It's that they're worried about my contributions on the side getting linked back to them and causing a reputational issue. So they just don't want any kind of association. Does that make sense? It's just up to the companies. Some are really strict about that kind of thing. Other companies are like, yeah, no problem. In fact, not only can you do open source stuff, why don't you just stream what you do for work, right? It brings us more, attention, and we like you, and you'll give our company a great name by just do work on stream. That would be the other end of the spectrum, right? Yeah, no problem. Okay, where did location come? Oh, that's right, because I pulled it out of here, so it doesn't know that it was in here. That's why. And am I not? Oh, error isn't in token. It is in there. Oh, that's right. I need to move. This actually shouldn't work. Oh, there's a token crate and then there's a token module. That's a problem. I should probably rename Lexer token, right? Let's give that a specific name. How if we call that Lexer, right? Well, it has a dual nature. How about Lexer output? Lexer output actually makes sense. So output. Yes, do it. Then this would use output, but we don't want to pub output it. We only want... Oh, that's because there's actually two different things here, right? That. Actually, we don't want to make any of that public. And location isn't there. And then from token, we actually want just the location. Let's call it as... No, this is going to be renamed, right? Output. Lexer output, right? And then token. Okay. Yeah, there's going to be some major changes here, right? Because token we're going to completely rename right now to be output. There we go. You do wish I could make it open source? Maybe one day it will be. I will at least get benefit from my streams. Starting a new project for a client in a few weeks, likely need to write your own version of this. Wait, you're going to write your own version of my tool? Or your own version of just the Lexer? Because if you just want the Lexer, then I can tell you where to... You could just go to Logos. They tell you exactly how to do it. Look, you can copy this stuff. It's a more, like, approachable introductory version of what I have. If you just want the parser, you go to Lollipop. Again, they have, like, an introductory thing that is, like, walks you through how to set it up yourself. Where's a good intro? Like the grant, well, yeah, like this. They walk you through it, so you don't need my code to be an open source. You could just go straight to them. I'm really just taking their stuff and adapting it to my own project, which hopefully you're not going to copy and make money off of because it's my hobby. And maybe if you were starting a project for a client and the client asks for what I'm doing, ask them how much money they'd pay for. Just kidding. Okay, I'm going to call that output, right? Okay, and how are we pulling it together? All right, this should be use... Oh, right, because we have to add the dependency on token. Token equals... far forget this. So let's just copy from here. It's path equals. There we go. Need a way to interactively reverse engineer some old binary formats they lost all documentation and decoders for? That's actually a great use for the tool I'm making. But you know, another way, if it's just for that format, what you do is you just start making a decoder for the format, and then you just iteratively, like, basically write a decoder the way a professional decoder would be written. You wouldn't use you wouldn't use Lexer or a parser. You would just you would have functions that represent how, like, decoding various parts, and then you'd have some starting idea of what you're looking at, and then you'd say, okay, let's make a function called get size or get header info, and then in those you would actually read the bits in exactly what they should be. I'm doing a more generic thing that really is only meant, it's for, like, it's open-ended. It's like you can do any format, but you're being paid for a specific format. Yeah, there is. Okay, I can tell you about a couple existing tools I know about. because other viewers have mentioned them. There's 010 editor. So here's something you could try. Apparently you can write a template. It uses powerful template technology to understand binary data. So you could download 010 editor and play around with their templates until iteratively try to reverse engineer those files, right? There you go. So maybe a better opening question would be rather than saying, is this open source? It would be, do you know of any tools available out there already that do this? And I would say, yeah, 010 editor. The other one was like, I can't remember what it was. If I remember, I'll post that. But you have 010. So how is it? Is it not good enough? Because I'm actually curious, if they don't have what you need, then what's missing? And let me make sure that mine has that. Want to be better than them, right? Why not? Why not shoot high? Okay, what's wrong with this? Trait bound token logos is not satisfied. Trait logos is implemented for output. Where did I say token? Oh, right here. Oh, yeah. Yeah, of course this is going to have an error because we have to adapt token. We have to adapt the output to the token, right? Because we're getting yeah, so this needs to be changed to output. Yeah, and so this is going to be a problem because it's not token lexer, it's logos lexer. Wait. Oh, no, it's output lexer. There we go. It's really cool, but the template's language definition is not programmable enough. Yeah, so what is it about how programmable it is? What are they missing? Here's an idea. Is 010 editor open source? You could start with their editor and then improve it. Do they have it on GitHub? Or is it closed source? It's proprietary commercial software. No! Oh well. We can ask, you know what I'm gonna do? I'm gonna ask ChatGPT a question off stream because I don't want to reveal what account I use to log in. I'm gonna ask, are there any open source alternatives to 010 editor? Oh, it says no. Although it says it listed 5 things we could look at: Hexfiend, WX Hex Editor, Bless, HXD, and Octeta. They're just hex editors, though. Remember, while these editors can handle basic hex editing tasks, they may not have all the advanced features of 010 editor. Oh, that's a bummer. Hey, maybe this is a small enough niche thing that I could make money off of this. Or I could do the ethical thing and make it open source. You know what I could do? I could start the process of getting formal approval to open source this tool that I'm doing right now. And then a year from now, when I get approval, I could post it on GitHub. Because I can open the request because I can tell them exactly what it is, and I can show them the source code. I can show them the C source code, and I say, I would like to open source this, right? And then I can just let that go through the process and see what happens. Okay. So maybe I'll do that, Taz. Maybe at work I will start the process of requesting permission to open source this. From what I heard, the process is very slow and it's not guaranteed. So I wouldn't get my hopes up. Okay, here's where we actually have to do some real adaptation. Actually wanted to have a hex editor like interface. Yeah, that's what I'm gonna work on. My goal was eventually to have a UI like this where you would at least have these two panes, and it would be nice if you could actually change a byte and have it get reinterpreted, or go into the interpretation and change it and have it change the bytes. One use for that is if the file is broken, you could repair it by going to where it's broken and then inserting a non-error alternative. That'd be awesome for the future. Yeah, wouldn't it be cool? If no one else has made such a thing, why not try to make some money off of it? Although if I were to open source it, then I'm basically saying, hey, this is free. So why would anyone pay me if it becomes free, right? I don't know how to make money other than to have a job, to tell you the truth. Just have to slog through the sum file formats by hand. Yeah, sorry. Actually, here we go. I don't think that it would be a problem if we were to pick a file format that's similar to the one you have to reverse engineer, and then like maybe I use that as something I work on stream. And then, while you're reverse engineering it, you could always ask me questions. Hey, how would I do this? And I would be like, oh, maybe do this. But it sounds like your work is more actually doing thinking and like, yeah, the reverse engineering aspect of it, right? So it's not like I or my tool could help with that directly. You'd want to like basically play with the tool and like trial and error, right? Okay, I'm kind of wandering around. I need to focus. Here, right? Okay, it's all here, which makes sense. So let me focus on this. So we want to output a token, and we get a output. We basically want to match an output to form a token, don't we? So we do an unwrap or else. I know what I can do. I can just insert a map here. And that should be defined. Expected output. It shouldn't expect an output. It should expect a token. Because we said token there. Oh, because of how this works. Yeah, so let's do a map right now, and we'll just put like output. Goes to a token. Add to do. Now it will expect a token, right? Option token. What? What? Oh, because of the sum. Option token? Oh, because it could be none. The next could be none. Yep. Because that's an optional output. Don't I want to do an inner map then? Map. Well, we'll get there when we get there. That resolved that type problem. Okay, so the parser, we have to update the parser, the grammar specifically. Not that huge file. This one. Yeah, we're trying to sever the lexer from the parser. So this error we don't need, right? Why would we need error? We shouldn't need error from the lexer. Yeah, I don't know why that's there. And yeah, we're using token, not lexer. That's the whole point of this. So parser should not depend on lexer at all. It should rely on token. Right. Completely severed now. Waiting for it to build. Are we actually building this time? Or are we getting a syntax error? Oh, we got a lot of syntax error. Wait, why is it using token? Still. Oh, wait. Yeah. Yeah, it is. This one does require us to be able to clone a token. So remember when I said, like, hopefully we don't need to make them clonable? Well, we do. So let's go do that. Token needs to be clonable. I'll be right back. Popcorn. Eating popcorn. Yeah, was that an awesome chair stream or what? Hey there, dude, man. I'm working on some refactoring before I actually get into what I'm now calling the ingestion part of the tool. So I'm refactoring right now these, kind of trying to separate them so that the parser should not depend on the lexer at all. Instead, the lexer should output something generic that the parser can ingest, or not, I shouldn't use the word ingest because that means something different. The parser should be able to get an input from the lexer that is not tied to the lexer's implementation. So there's going to be an intermediate that wasn't in the C. It's called token. This will be the output by lexer, input by parser. So this will be a separation of concerns between the lexer and the parser. This has no dependencies. So the lexer generates a token and the parser can input a token, and the parser is now independent of the lexer. Best chair stream yet? Those are the reactions on Mac OS now. You can do that. You can do that. I can make it rain if I do this. There, it makes it rain. Will the lexer output the token list? Yes. The lexer will output a list of these tokens. So we'll show you that. The lexer, its formal specification is that it is an iterator of item, where the item is a token and beginning and ending locations. Is that built into Mac now? Yes, it is. You can also do a heart shape if you're into that. There we go. And there's also single thumbs up. And what was the other one? I think single thumbs down does that. I can't remember if there are any other reactions. Yeah. I only get it because I'm actually on a Mac Studio. This is Linux, but it's in a virtual machine. One reason I do that is it's really easy to separate the streaming stuff from the private data. I can't accidentally leak anything, not even my account. Who am I? has any personal info. I'm just Raimu because the VM is just for streaming. The cost of that though is that I have to do an extra step to check my code into my private repo. So I do a send to send the stuff out of the virtual machine, and then I have to remember later outside the virtual machine to check it into Git. Saw an article about these reactions making telehealth therapy awkward. Yeah, I saw that too. It's that by default they're on, and so some people like use hand gestures or just the shapes in the background when they're talking, and then it'll accidentally do a thumbs up when they're talking about something sad, or a thumbs down when they're talking about something happy, or and then that could be inappropriate. And especially in a therapy session, you don't want that. So what I read is that now therapists are posting like warnings, like notices, like when you are going to connect into your session, they say, make sure you have this thing turned off before you enter the call, because this stuff by default is on and it could be awkward, right? So my personal opinion is I think that it wasn't intentional, and they'll probably change that in a patch at some point to make it not a default, not on by default. Because that moved to AST, right? Okay. Yeah, so my Lexer implements an iterator. So you basically, when you make a Lexer, you just call next on it over and over again, or use it in iterator context, and it gives you both the token and then where it begins and where it ends in the input character stream. Is it through a specific app? No, it's just any kind of camera capture. That's why, like, I'm in OBS and it just works even though they didn't change anything in OBS. You haven't updated the newest version of macOS. When you do, you'll see that you get that. So it'll be like in OBS, your normal camera, like photo booth or WebEx or Zoom or whatever, it'll all be on. Yeah, so you'll probably want to turn it off. It's in the settings somewhere, I think. Yeah, so that's answering that previous question of is Lexer output like a token list? The Lexer is an iterator of tokens and their locations. Yeah, so I added another, and this one actually was in C, right? Actually, I think it was just built into that, so it really wasn't separated, was it? So this really is not applicable. I'm adding one in here called the AST. Definitions of the AST types. Because again, we want a separation between the parser, which outputs an AST, and the ingestion, which inputs an AST. So we don't want ingestion to depend on the parser. You might already have an AST, and you shouldn't have to build the parser into it if you already have the AST to start with, right? Also, this helps me with unit testing. When I test the parser, I don't need a Lexer, and when I test ingestion, I don't need a parser. Okay, so where was I? I was in the parser. It has to, the grammar has to actually work with output. Well, it has to work with token, which it does now, right? Was it down here? I need to change some of this stuff. Token, we have location, but we don't have error. I think we're picking our own error type, right? So that would be use create error. And I just need to make sure I have an error type somewhere. Yeah, this, I guess we're just using crate error then? Yeah, just using, whoa. What happened there? Yeah, we're just using crate error for that. Aha, token. Waiting for the clippy, waiting for the clippy. Clippy, 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 test message format JSON, diagnostic rendered ANSI. All right, tests. Same thing, no longer dependent on the lexer. Error is our own type. Use crate error. What's wrong here? Semicolon. There we go. It's a little unnerving that that compiling takes so long. Oh crap, that's gonna be a lot of places, right? So maybe we do a search and replace on this one. So we're gonna turn use lexer location into use token location. Yeah, it's 28 different places. So let's control alt enter. All right, search and replace is cool, I think. What's it saying? Binary operation equal can't be applied to an AST expression. Parse error. What's it trying to say? An implementation of partial equal might be missing for error. Oh, it is actually. We need to do a partial equal there. Why didn't I need to do this before? Oh, we're using the wrong kind of error. Shoot. There was an error from, oh, right. That means all the places we're using error are probably broken now because they're going to say parser error, which was what they should have said from the get-go, right? Well, wait a minute. No, these are internal tests. Okay, then I made a mistake. Like these don't depend on where do we import that error? I guess that's in the tests folder. It's using the wrong error type. Yeah, we're not using crate error. We're actually using lexer error. We need to make lexer. Let me think about this. Like, let's look at an example error. That would be in like expression 0, right? Where do I use an example error? Parser unrecognized. Oh, wait. That's parser error. So why don't I just make that, and that's parser error. Right. That error. Oh, I know what it is. Yeah. That error we get to say what it is. And I used to say it was a lexer error. So what are we going to say it is now? It's down here, right? Way down here. Like, what error is it? This used to say, it used to use the lexer's error type. What error type are we using now? What one do we want to use there? Our own error type, right? So then, okay, I'm trying to ask myself then, where do we ever use that value? Where does that come out? Here? Parser error unrecognized token. Yeah, where do we use that error type? Oh, it comes out here. Custom error type. We don't need one. Can I just make that unit for now? Because we're using all of these, but that doesn't use this E at all. It's user error. Okay, so then the question goes to where do we actually need that anywhere? Do I use error anywhere here? None of these use error, right? Yeah, we don't need error. We don't need that. Error is now a unit. We don't use user error from the parser because everything is a parser error now. Where I would use a custom error is if we actually made an error grammar rule. If I use an error grammar rule, then I'd want to use a custom type there. And I guess we would declare our own error type up here, I guess. We do have an error type outer, right? Yeah, it's here. But that, why did I have that? Because I wanted to, this is independent of Lollipop. So it has to encapsulate what parse returns, which is a parser error, just like these tests are generating, right? Parser errors. So I wanted to map that to what the user would see. That means I actually might want to have two different errors, an external error and an internal error, which comes through as user error. Okay, then I think the way I would do that is if we wanted an error type, rather than doing a unit there, I would declare an error type up here, and it would be a grammar error. That's what I'd probably call it. Grammatical error. Grammatical error, right? So you could have a parser error which contains a grammatical error because it would be a grammar rule is returning an error. Actually, and I don't even know how to report an error from these. I guess if we had a result, the result would use the error type. Yeah, probably. Okay, so then to solve the immediate problem, all of our error types are now unit. Actually, how about we make this future proof? We'll do this by declaring that type out here. Type grammar error. And just we'll map it to unit right now. And then we'll use this. This has to be public. And we'll put it in here. Then from the top level tests, we can say use grammar error. And I have to go into, how would we find this? I guess we can just compile the grammar. It's grammar, right? I think that's what we would get. And then I can just use that in all the tests. Grammar error. Failed to run custom command caused by unexpected token pub. Oh, I can't declare a type there. I can only do a use. So that means I want to have, I guess I would I don't want to declare it here. I mean, I guess it could. Let's make another error where we pull things around that we want. So from lib, yeah. Let's remove error from the lib. And error, we paste it there. That didn't quite work. Let's try again. Cut, save. Select all, paste, save. Lib has mod error. Okay, and then I should be unambiguous about this. So error will be parser error and grammar error. Okay, and then we'll have placeholder. Actually, for grammar error, it's just going to be pub type grammar error equals unit for now. And in the grammar, we will just say use crate error grammar error. Okay, so we're good with the parser generator. It just didn't like in the lib. I used the word error. Yeah. So if I hit like save here, it should see it. That needs to say grammar error right there. As soon as this is done, there we go. So can I just say that? It's not going to like that, right? If I import that, I think we'll just put the value here, which is unit. Oh wait, no, that's not a. That has to be a parser error. Shoot, not a grammar error. There we go. Okay, and then unresolved path grammar. What is the path to that? Oh, we get that through like here, right? It's crate grammar. Like that, right? What's the error? It's private. Oh, this is wrong. That's right. We don't need to get it through the grammar anymore because the grammar gets it from error. So then let's just search for place since it's easier that way. It's only one place? No, it should be more. Yeah, use crate error should be... No? Huh. It's just this file. Okay, well then that's crate error parser, a grammar error. I'd have to say grammar error in all of these places, don't I? 25 places. Let's see if I can just take advantage of search replace again, and I do this. Change all of those to put the word grammar in front of the word error. 26 places. Easy. Cool. So only one warning? Does that mean it's going to build? Can't be that lucky. Actually, looks like it's building. Oh, wow, it built. Wow, cool, it built. What's that warning about? Unused variable in the lib of parser. Wait, that's parse. Parser. Oh, lexer. Lexer source lib. Here. Output's an optional output. Oh yeah, we're not doing anything with it. I forgot all that. Yeah, okay. I need to have an adapter. it's going to be a big match statement. So let's put it in a special function. I can make an impl for output, right? That goes to token. That's probably the best way to do this. So it can go here, impl from output for token. And then back in the lib, where is it? Back here, I can just say map it's a map, right? Because transpose gives me a result option. And then I'm mapping the option output, and so I have to do a map that, right? Yeah, I can do a output dot map token as from output. Into. It's the other way around, right? Into token. Implementation for output, right? I think that's it. I wish I could just say into, but I don't think it'll let me do that. Maybe it will let me do that. It just figures it out. That's cool. Neato. So here we're translating with the into, we're translating from output to token because it goes from output and it becomes a token. We don't need to say this anymore. The double map, the map means because we actually have it's two levels nested. It could be an error. If it's not an error, then it could be a token, or it could be a marker saying that we're at the end of the file or the end of the stream. So if it's not an error and it's not the end, then convert, that's what into is, convert from an output into a token. And then the unwrap or else takes care of the error case. And then we turn an error into a special kind of token, which shouldn't be in the output at all. These two kinds of errors get turned into tokens. All right, so then I just need to implement for output. How to convert from an output to a token. So that's a match value. Fill all arms. Okay, let's do a little trick here. Let's take all the to-dos, delete them, go 3 words over, 4 words over. Oh, that doesn't quite work. Have a beginning of the line. Can I just go to the beginning of the line for all of them? I can't. There we go. I did it. But I lost. Okay, let's try it. Let's try again. Delete, end of line, beginning of line. There we go. And then we can take 3 words, copy, go to the end of the line, paste, go back 2 words, put self : there. Now that gets the majority of them, right? But we just have to fix up all of these. So that's like S D, D, I, D, 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 I, right? And then S. Cool. Cargo test. Lib. This should just work now. I shouldn't have broken anything, right? Ooh, hey there, rabbit. Hey, look, didn't break anything. It's all good. Passed all of our tests. So, I wish that these all said Lexer in them, but they don't. But yeah, we have 112 tests for the Lexer, and they're all passing. And then we coincidentally have also 112 tests, but for the parser instead, and they are all passing. And I have no unit tests for token or for utilities, and AST should have said that there's no test. Yeah, there's no test for AST or ingestion. Actually, where are the AST tests? There aren't any. Why aren't there any? Oh, because there's no code in AST. There's just data structures only. Good morning, Grawful. Just a quick overview. DataDisintegrator. What it does. Actually, why don't I just write here what it does? Terminology. Pull apart all the bytes of some binary file or stream and assign meaning to each one based on description of the format of the file or stream written in a domain dash specific language, DSL. So I'm working on a tool which pulls apart all the bytes of some binary file stream and assigns meaning to them all based off of the description of the format. So I've been playing around with GIF as an example. So here's an example of my domain-specific language. And if I put side to side with that an example GIF file, why is this trying to scroll? I think that's a bug in VS Code. That's definitely a bug, right? Before it scrolled off, I managed to grab it. Okay. Here's an example of what the original tool that I wrote 5 years ago does, and I'm basically porting it to Rust. So given this description of a GIF, here's the actual bytes from a GIF file. It figures out that, oh, because the GIF starts with a header and the header has a 24-bit signature and version, that those first 24 bits, GIF there, that's the signature. The version is there, which is 89A. And then the next 2 bytes here, 2C and 01, well, that's 44 and 1, the least and most significant bytes of an unsigned integer of 16 bits that tells us the logical screen width. So that's just an example. I can write any format I want using this DSL. I could maybe describe a JPEG or an MPEG stream or a save game file or a WebSocket packet, TCP packet, like kind of what Wireshark does. Could do the same thing with this. And this is all for fun and practice and playing around with Rust. To fix this scrolling, I think I'm just going to close VS Code and open it again. Yeah, see, it's a VS Code bug. It's not scrolling anymore. Okay. I've mostly today been refactoring out the parts of this tool. There are basically 3 parts. There's the Lexer, which turns the input program into a token stream. the parser, which turns the token stream into an abstract syntax tree, and then the ingestion, which is going to use that AST to break down the binary data into elements to determine their meanings. So these are all written both in C and Rust. This is only written right now in C, and I need to write the Rust version of that. But first, before I started that, I wanted to insert these abstractions between steps 1, 2, and 3, so that the parser does not depend directly on the lexer anymore. The parser and the lexer both depend on a token library, which just describes what goes between. Same thing for parser and ingestion. So the parser outputs an abstract syntax tree, and the ingestion pulls in an abstract syntax tree, and I wanted the actual types to be in a third library that the other two depend on. So if I did this right, and I go to my parser, it should not depend on the lexer at all. Yeah, so it depends on the abstract syntax tree and the token, right? That's the output, that's the input. It depends on some random libraries, and then lollipop is what we use to generate the turn the grammar rules into the parser implementation. So I achieved the goal, right? It has nothing to do with lexer, and lexer shouldn't have anything to do with the parser. It only depends on logos, which is how we implement the lexer, and the token type. So they have a shared dependency. One might call this a form of dependency injection. So we're injecting this token library into both of these other libraries. Or you can call it just an abstraction. It's the interface between the two libraries. I guess the way where you'd have the dependency injection is in programs like parse, where on purpose we will adapt the two things together. So the way that works is we create a lexer, and then we create a parser, and then we tie them together. So we inject the lexer into the parser through the parse method. And it works because parse is generic over anything that can be turned into a parser input iterator. Parser input iterator is an iterator whose items are tuples, and it's 2 locations on token. So that's formally the interface between the parser and the lexer. So the parser takes that. It means the lexer has to generate that. And we could see that if we go to the lexer's implementation of iterator, we see the same tuple. And if you're curious why location is twice, that's because a token has a beginning location and an ending location. So sort of like graphically depicted here, there's a location before the token and after the token. Tells you exactly which lines and columns the token is in. When I say token, by the way, I'm talking about from the original file that you'd input. That's a token, there's another token. And I have a little test file, a test program that just wraps the lexer that kind of illustrates that. So here's what the lexer would output, like turned into like debugger outputs, right? This is one value of token. There's another token. There's another token. You can see I kind of am printing the 2 locations after the token. So this is saying, because we count from 0 internally, it's line 0, column 0 to column 3. So that's that, right? And then left brace is from 4 to 5. So that's what I mean by token. And it could be a reserved word, it could be a literal integer, it could be a punctuation. They're just different kinds of tokens. And if I show you that, we've refactored that out so it's completely independent of the parser and the lexer. It's just a plain old data type. The only thing special about it is we generate clone, debug, and partial equal implementations. So clone means you can call the clone function on it, and it will just give you a copy that has its own separate allocated memory. So like if it's an identifier, the original token and the copy of the token will have different allocated strings, and they'll have the same contents copied. Debug makes it so that you can take any value of this type and print it out in the debug formatter. And partial equal means we can compare values of the type, whether they're equal to each other. If we wanted to compare them in order, like less than or greater than, that's the ordinal or ord or partial ORed we would have to implement. So we can't do that. There's no order between these token types. We can only compare them for equality. By the way, the reason why it's partial equal is that's saying that A equals B is not going to necessarily give you the same answer as B equals A. If it's reflexive, then you'd also implement equal. That's the stronger type. This is basically saying that we reserve the right to be non-reflexive in our equality. So yeah, you can see it's, in fact, I can remove this credit because that was for the, really for the regular expression. That doesn't apply here. And same thing here. Glad I went through that because I could clean up these comments. So that directive we don't care about here. Actually, I don't even think I need this token at all. It should never be emitted like the comment said. It doesn't get emitted to the parser ever. So the parser will never output. Oh, wait a minute. No, this is between the two, right? So we have to have it here, but this is a note just saying it should not go to the parser. Yeah, okay, we're keeping that. Okay, and then the other interface, so to speak, was this AST library, and I just made that today. And it has all the things that you would turn this into. So like that's a format, that's a statement, this is a conditional statement. So if we look in AST, we'll find all those types. Here's a format, it has a name, arguments, and statements. A statement can be a conditional, and the alternatives of a conditional have a condition and the statements if it's true. And there's also the otherwise or the else part if we have one. Right? So these are also going to be completely independent of the parser and the lexer and the ingestion on purpose. So it should not have any dependencies. So it only depends on the utilities. I actually don't even know if I do need that, right? For some of the debug implementations, I'm using that. Yeah, for this right joined when we're writing things out. By the way, here's how you do how you implement display or like formatting for a type. If you implement display or debug, you get one of these formatters and you can write to it through a write macro. So that's if a value of type statement is ever printed out. We would turn printing a statement into printing a bunch of text, right? And an example of like where we would see this is the tool I wrote, which runs the parse tool. Here we go. So again, we're parsing this, and we can see like text like that is whenever we print out the individual statements in a format. So like we'll find GIF in there somewhere. There it is. So that corresponds to this. You can kind of see the structure is still preserved. The order of the parts, a part being a kind of statement, which is specifying that this will actually parse some part of the GIF, right? Whereas a local is just a declaration, and a while turns into a loop with a condition of 1, which means always. Ignore means we're parsing bits, but it's not part of the GIF. It's where we're ignoring those bits. And that's because we're doing a look ahead. That's what the plus means. We're saying if the next 8 bits is 3B, then break out. Otherwise, the next part is a data block. And then once we break out, the last part is a trailer. Anyway, I know I covered like a gazillion things there. I figure if no one's chatting and asking questions, I'll just keep talking. And then I'm kind of double checking that I did everything I want, and then like basically getting everything in order so I can do the next step, which is this ingestion library. So we need to write a library that uses the AST to break down binary data. So we need to pull in the AST, and now we also have we have to have an interface for pulling in binary data, and then we're going to have a function which basically walks through both at the same time. And it's going to if we were to output that, it would look like this. That's starting at bytes at offset 0 in the file, and at the top of the GIF, we expect a header, and the header has a signature, and the signature will tell us to parse 3 bytes as a string. Okay, let's do this. We have to start somewhere, right? I already have a placeholder for this, but I think it's empty. Yeah, it's just got placeholder. Just don't be silence. Silence makes it boring. Of course. It's because I'm not playing any background music. The only time that it wouldn't be boring is if we were all meditating and I said, let's all be mindful of our breathing or something like that, right? Okay, let's remove the placeholder and actually do a real test. So fundamentally, our tests are all going to have an AST and some binary data, and they need to do something with it, right? So let's take like the most basic AST we can make and like see that it does something with it. So I'm thinking like a format with just one part statement, which is a built-in that just like reads 1 byte. And so we'll have an input with just 1 byte. So let's do that. In fact, actually I already know that I want to use the test case library. So let's use that. It's a dev dependency. Let's use the dev dependency called test case because it's really useful. In fact, it's so useful, I'm going to copy from an existing test. I'm just going to copy this thing and we're going to like make, whoa, why is it running stuff? Probably because I told it to. Delete, delete. I think I misclicked. I told it to run that in a debugger or something. Let's copy all this stuff. And paste it in ingestion lib, sure, right here. Okay, so input is going to be a AST set. So that was a hash set string format, right? Did I have a nice type alias for that in parser? No, I just call it that. Maybe I should define, actually this is the actual output. But I don't need to test with errors, right? I only need to test with real ASTs. I think I will not bother making a type name for that. We'll just make sure we use it over here. Right. And so the expected output, actually there are going to be 3 things, right? There's the input ASTs, and then there's the input bytes, right? Or bit stream. So I'm thinking ahead that we might want to parse like a stream that has no end. So it can't be a file, it can't be a buffer. It's got to be an object that we can like pull bytes from. So let's have it be let's have the real thing accept a trait, and then we'll manufacture an actual like thing we can use in tests. So it'll be like a mock bit stream, or actually I guess we can make a formal one called like a buffered bit stream. And then let's just have it accept an array of bytes. So we literally give it a slice of bytes, and let's just put like some byte in there, like 12 or something, hex. Okay, and then the expected output, What do we expect from the ingestion? That's a good question. In general, what's the engine, the ingestion engine going to do? It's going to give us a value, right? Basically a composite value. So we're going to have some kind of, like ingested value. What's a good name for an ingested value? So like, I hate to use the word value, but maybe that's what it is. It's some value. I need a better name for that. Ingested value? Interpreted value, analysis value, ingestion output. It's a value that represents what the data is. So what to call this? Why doesn't it like my 12? Because it doesn't know what the type is. We'll tell it what the type is in a minute. Expected output. I think the problem is I remember actually just calling it value in the C code because I didn't have a better thing to call it. In decomposition, right? I think I just called it value. Yeah. I just said that it represents an informational element or group thereof assigned to a component or attribute of component in a hierarchy that together expresses the decomposition of some data. And then I said, what do I name that? How about I just name it value? So maybe from this text, I can be inspired by what to call it. What if I could just call it decomposition? No, that's too complicated. What if I called it data? And a data could be of these different types, right? It's either an integer, decimal, string, vector, map, or set. Yeah, let's just call it data. So it's in, let's just call it data. Because that type doesn't already exist, right? Yeah. There are things that have data in the name, but so this is a completely new thing called data. We expect some data as output. Okay, then let's like theoretically write what we would do there. I don't need to do this map, right? This we don't need to do at all. It's just that we expect some new ingestion given the input ASTs and the input bit stream. What if it does it even need to be an object that we can call parse on? Actually, I'm thinking it should be like we might want to have one ingestion thing that has a bunch of ASTs and then be able to pass it multiple bit streams. So it'd be new input ASTs and then dot ingest input bit stream. And then the output of that is our data. I think that's what I want to do. So the ingestion will give us some kind of context object that we can, oh wait, the ASTs it doesn't say how to ingest it. So I think we have to actually say we have to ingest it as a certain format. So we're going to have like a format identifier. That's going to be the top level format, right? And doesn't it makes sense to say ingest this as this. Okay, we'll start there. I have to fill in, I have to actually make a type called buffered bitstream. I have to make a type called ingestion, and then we have to have two different new methods and an ingest function. Okay, but okay, how are we going to describe the input ASTs? Is going to be, it's hash map, right? There's another helper library we could use there. Maplet, that's right. We're going to use Maplet. So with Maplet, you could do cool things like Maplet, hash map, right? Hash map. Like this. So to use that, we use Maplet hash map. Okay, and then I guess to use test case, we also have to do use test case, right? Okay. So it's a hash map. Which looks like this. Something and then big arrow, something else. Okay, actually, why don't I just steal that? Because that makes it easy, because that's an AST right there. That's an AST which has empty statements, right? So that actually won't parse anything until I give it some statements here. Right. So then we have a vector of statements and we need at least one statement. We'll make a part statement and we don't know what that is yet. I need to resolve all these other errors, right? I wish I could get some help from... Well, I guess we'll just look it up. I was going to say, I wish I could get some help from Rust Analyzer, but it won't help me because we have syntax errors. We'll just peek and see what a statement has in it. The statement part has these things in it. So copy and paste. And tab over arguments. Empty vector. Bound is not... actually, bound, if I'm going to use the built-in integer, it should be some... and we'll just say expression literal integer 8, because we're going to say it's an 8-bit. The format's going to be UI. The interpretation is none. Look ahead is false. L value is none. Name is... should we give it a name? I think we should give it a name. We'll give it a name sum bar to string. Okay, so this is a format called foo that has no arguments and it just has one statement which says inside foo there is a bar which is an unsigned integer of 8 bits. So we would expect that if we were to parse, if we would give it a buffer with a single byte 1, 2, what we should get out of it oh, what am I doing here? This is wrong. That should go up here. And the expected data, it should give us, because we didn't say anything here. Actually, I guess if we added a return statement, we would be able to get it out, right? So let's add a statement return. Return statement just has the expression in it, right? So the expression here is expression reference. Which has a vector in it. And the each thing in the vector is a reference. Oh, this also has to have a reference here, right? Reference part. reference par. I'm doing all this from memory, by the way, because I didn't do this too long ago, right? Because a reference is a new type for vector of reference parts. A reference part has an ID and an indices. So I don't need this. No, that's because that is itself an expression variant, which is here. Reference. So we have reference, and inside of reference we have a vector, and inside that vector each element is a part, and the part has an ID and an indices. So ID is, we need to have it return bar, so we have to have that same thing without the sum, actually. So we're going to parse bar and return it, basically. Indices is empty vector. Okay, that's a very complicated way of saying the format foo is parse a byte and return it. Because we want to see that the data is a integer, right? Of 0x12. We want that byte that we pass in here to come right back out, because we interpret it as a literal 8. So then, like, variations on this test might read it as two 4-bit values, for example. So I might read it as two 4-bit values and I get a 1 and then a 2. So that might be another test that we do. Okay, so the input bitstream here, I guess we're just using bitstream. Okay, so this is not going to work because of lots of different things, right? That's an interesting error, though. It says unexpected end of input. Oh, because of that comma. There we go. Now it doesn't know what all these types mean. I don't think we're dependent on the AST. That's the problem, right? Oh, we don't need the lexer in the parser, do we? Yeah, this is severed for a reason. So we can just say AST, not depend on those libraries. There we go. So now I should be able to say that format comes from AST. Statement comes from AST. Expression comes from AST. Reference comes from AST. Reference part comes from AST. Hash map comes from collections. Okay, so these are the types that we need to define minimally: bitstream, data, and ingestion. So let's do data first, since that's going to be the smallest work we need to do. So we're going to have a data.rs. From lib, we're going to have a mod data, and we're going to want to use super star, and we're going to want to have pub use data. Okay, and then in data, we're going to have struct enum data, pub enum data. And then the only thing we need right now is integer I64. All right, so that's it for the data type. Now we need ingestion. All that needs to be able to do is call new with the hash map and ingest, take a trait, which we haven't defined yet, and a slice. So we're going to want to do pub use ingestion. Okay, and then a new module called ingestion.rs, and in there it's pub struct ingestion impl ingestion pub function new, And we have to accept the AST, right? And actually, we only need to borrow it. No, we don't want to borrow it. We want to actually own it because it's easier that way. So it'll be formats hash map string to format, and then we're going to generate a self. And then we also need a ingest, the pub function ingest. And then here we're going to take the bit stream we're going to make this generic off of some bit stream, a B bit stream. And the top level format, which is a string. And it's going to generate a data. Okay. Hash map we can deal with a use. So can we with format. We haven't defined what, no, we have data. Define data by importing from the crate. Okay, so we need bitstream. So yeah, we need mod bitstream. Pub use bitstream. Okay, and then new file. Bitstream rs. So this is pub trait bitstream. Empty for now, right? Ingestion will import from the crate. We'll just have it return data integer 40. We'll just cheat to make the test pass, right? And then lib, we're just missing bitstream, buffered bitstream. Oh, and we need what's wrong with ingest? Oh, it's supposed to take a mutable reference to self. That's probably why it doesn't like it. This has to take mute self. Okay. Okay, data is not equatable. Well, we can solve that by doing pound derive partial equal. Actually, while we're at it, let's do debug. Let's do partial equal. Okay, back here. So now we just need to say what buffered bitstream is, and I think it's useful to export it out because whenever we have a slice of bytes, we could use a buffered bitstream. So why don't we just do mod buffered bitstream and just export that as well. Pub use buffered. Okay, so new module, buffered bitstream.rs. So pub struct buffered bitstream. And then it has to have an implementation because we had it a new, right? Pub function new. And it took bytes, which is a slice of U8 self, right? And for now, we don't actually need to do anything with it. We can just say self. Okay, and then save again. It didn't like that. Why? Did I misspell it? Yep, I misspelled it. Okay, and then, yeah, the only thing left, I think, is that it's going to say this doesn't implement the bitstream trait. That's exactly what I thought it would say. So to make that work, we do impl bitstream, which comes from crate for buffered bitstream. And that's all we need to say. Now it'll just work. And our test will pass and we'll be done. Yay! Cargo test. Can I say like for project ingestion? Or is it lib? I can't remember which one it is. That runs them all, though. What if I wanted to run, what's this depths? Depths. I don't know what it's doing. If I just do lib, it runs everything, right? Yeah. Cargo test help. Package, not lib. Or we can just do p. And then I can also do a dash dash lib to not run the doc tests. There we go. Wow, look at the name of that test. That's the default name. That's crazy. So we should not use the default name. We should actually give it a name. So we do that by doing a semicolon here and the name for the test. We'll name this, oh, it's like, so this is test ingestion, or ingest, right? So test ingest a byte. Test ingest a byte. Yeah, package was the answer, yeah, or lowercase p. Like that. So we passed because we cheated. I cheated by saying that the ingest always just returns it. We're not actually parsing. That's mostly because I wanted to make sure the structure is right, and also because it's actually a lot of work to get from this plus this to that. So I need to do this incrementally in little baby steps. Okay, so what if the first thing we do is, rather than having the 12 come from ingest, what if we have the 12 come from the bit stream? So we would do something like bit stream. The typical thing we're going to do with the bit stream is we're going to ask it to give us a certain number of bits. And let's say we're going to ask it for 8 bits here, just hard code it, right? And then it's going to give us like an unsigned integer. So let's take that and just put that in there, right? Okay. Problem is that the bitstream has no method. Oh, wait, what? Oh, R. Mistyping, so yeah, mistyping didn't have the R. There's no method named bits. So what we can do is we can say bitstream needs to have a method called bits. So function bits, which mutates the self, and we ask for a number, n, usize, and it's going to always return us a U60. Should I do U or I? I think I should do U. Right? Now we have a problem where we actually have two problems. Problem is this is going to be a U64, so we're going to interpret it as an I64. And then the next problem is that it's not mutable, so we say, hey, we're going to mutate that. And then it'll work until we get to here where it says there is no implementation, so it'll implement missing members. And here's where we're going to totally cheat. We're going to return 12 again. And incrementally, we just leveraging the same test to show that it passes. Okay, so then let's do the next thing, which is that it actually came from the slice, right? So we'll just store the slice here as a vec. I guess we'll have to store it as a. We could borrow it, right? We could. Why don't we do that? So we'll make it generic off of some input. So we have just the input, which is a borrow of lifetime input, the bytes, right? So then what we do, actually, can I do the anonymous lifetime here? Will it let me get away with that? Ooh, it will. I just say input here. Looking good. That's right. Hey, look, I can do the anonymous lifetime. There, I can't use the anonymous lifetime there because it'll actually freak out and say, hey, I want a name for that. Here, we'll try, and I'll show you what it does. it freaks out and says it has to be a named, you cannot use that here. That's a reserved lifetime name, F off. So fix it. Okay, there we go. All right, can I do the same trick here? I think so. What's this? Lifetime may not live long enough. Okay, so there's the problem. I have to use the same lifetime here, right? I have to actually say here. So here's where I actually want to have the name because I want to say that these two lifetimes are the same. Do I have to say that? And I have to declare it, actually. The way you declare it is you have to put it on the impl. Okay, now it works. So now that we have the input borrowed, here's where we get into funky Rust stuff that I actually know how to explain. And it's really a nice intro to lifetimes. So what does this mean? This means that somewhere there is an array of bytes. It's somewhere, right? It's a type. And input could be the array, right? It could be, but we've decided that instead we want to borrow someone else's array. So you do that with the and sign, right? The problem with Rust and borrowing someone else's data is that Rust wants to know how long you're going to borrow it for. So we're going to basically say, we're going to borrow it for no longer than some lifetime that we're going to call input, right? Now you can do that and make a structure and store that borrow in there if you also say that your type also lives no longer than that borrowed, because if it lasted longer, you would be able to hold on to data that longer than it might get deallocated by the time your structure goes away. So when you store a borrow in something else, what you store it into has to live at least as long as the longest lifetime inside. Right, so that guarantees that if we have a buffered bit stream, the compiler's already done the borrow checking to make sure that the input inside will always be valid for as long as this outer structure is alive. It also tells you when you look at this that this buffered bit stream has some kind of borrowing going on inside of it, right? That should be your clue. There's something being borrowed. And then you look inside and you see what's being borrowed. Oh, we're borrowing someone else's array of bytes. Okay, so then when we actually do implementation of new, what's happening here is you can say, well, you can have a new buffered bit stream if you give me a borrow for an array of bytes. And the lifetime of that borrow is going to be the same lifetime as what we're going to give you back. Hi there, Water Serpent M. So this is all just like elaborate syntax to have a contract set up saying that if you give me a pointer to some array of bytes, I will give you back a structure that holds onto that pointer for only up to, but not beyond, the lifetime of the pointer you give me. So the compiler figures out if you break these rules. You're basically signing up for, we can put a pointer inside of a structure as long as that structure doesn't live longer than the pointer we put into it. All right. So, but what that allows us to do is we don't have to make a copy of those bytes. We're kind of like able to work with something that we passed in earlier. We can continue to work on it even though we don't own it, which is super useful because this array could be huge. It could be a gigabyte, right? And if we wanted to have an independent lifetime, we'd have to make a copy of all of those bytes. You run out of memory real quick if you had a lot of these, right? So this is a zero copy architecture. We're basically saying we're not copying the input. We're just borrowing a pointer. We're holding on to a pointer to it. We're borrowing access to it, right? We're also saying that we're not going to change it. To change it, we would have to put the word mut there. Now we're saying that not only are we borrowing some array of bytes, but we're planning to be able to change it at some point, which is perfectly valid. I think that goes to the right, though. Yeah, it's perfectly valid, but we don't need that. Mutable access has a lot tighter restrictions. Once you put that mutable reference into that buffered bit stream, Nothing else can borrow it. In fact, it can't be touched outside of the buffered bitstream until that buffered bitstream is destroyed. Doing this, it's a much looser set of restrictions. It's basically no one can write to it now, but it could be shared with a bunch of other things. That's fine. Which is actually what we want, right? If we're going to buffer a bitstream and parse it, we don't want anyone else to change these bytes. So let the compiler guarantee that by saying that we want an immutable reference that lives as long as we do. Okay, so now that we have the input, we can merrily steal from it. Like that. As long as we convert it to a U64. And this should just work. And it does. Woohoo! Now where this breaks down is where if I make another test that wants to read like maybe only 4 of the bits at a time. So let's make a unit test for that. Unfortunately, like my tests are really long to define. You know what we could do though? We could put this into a function, right? Would this be cheating? I don't think so. Function example AST foo returns us a basically what we want, right? We want a hash map of strings to formats. And then just put the hash map declaration inside there. And then we can just call it right here. Look at that. Make sure that still works. How frequently do you write tests? As much as I can. I follow the rule where I try to test early and I test often. The earlier you can test, the quicker you'll find your bugs and the more confident you'll be in the correctness of your code. So I'm doing almost exclusively unit tests. And this is on top of using Rust, which does a bunch of testing at compile time. So Rust will catch race conditions, like buffer overflows, type differences. It'll check and test for that, technically calling a test, check for that at compile time. So if this compiles, I know I passed all of those tests. Okay, I've been informed. I must stop for dinner soon. Yeah, but yeah, I'll have to end the stream soon, but I should be streaming tomorrow morning. We'll continue then. Do you ever find code or class too simple to not warrant a unit test? It just means that the test is going to be simple too. But yeah, if you had a function that returns a random number from 1 to 10, I wouldn't bother testing that. I would just look at it, and if by inspection, if the function only has 1 line and you can see that it's correct, I wouldn't bother writing a test for it. No. I would probably draw the line at if it's more than like 2 or 3 lines of code, then it probably deserves a test. Even then, like if it's maybe 3 lines long and it calls some other things, I might start to think, I might want to test that because it does call some other things which could be testable on their own, but it maybe combines them in a way I want to test them. Like if you had a function that did the multiplication of 2 numbers that it got from calling some other functions, I might want to test that just to make sure it's multiplying and not dividing by accident. But yeah, that might be a little bit too verbose. It's been an internal battle of mine, finding tests. There's a general rule that you should probably spend as much time running your tests as you do writing your code. If you spend less time writing your tests, you're probably not testing enough. If you're spending more than half your time writing tests, then you're probably testing too much. You could also follow the regression rule where you only write tests when you have a bug, and the tests are targeted towards the bugs, so that if you can write perfect code, you don't need any tests. If every time you write a function, it's got a bug, then you're going to write a test for every function. That has the positive side of minimizing the amount of tests you need. It has the drawback of you're going to let some bugs through. You're going to have what's called regression at first. Your code is going to regress or go back to a bad state at first, and then you're going to add a test to make it work again. And then if it's a particularly complicated function, it's going to regress a lot, which will force you to write more tests. But then in the end, if you're able to get through that painful maturing period, you'll have exactly the correct amount of tests to how good you wrote the code, right? Again, you write it perfectly, you never need to write a test. If you write it poorly, you're going to end up writing a lot of tests. Okay, I wanted to use that because this allows me to make another test really small that'll fit on the screen. This will be like 2 nibbles. And here, with the same AST, we're going to give, actually, it's going to be slightly different, isn't it? Shoot. Oh, I know what we can do. We can have the bound as I64 be passed in. So this could say 8, and this can say 4, and we would expect to have, let's do something with this, right? We want to return, crap. Actually, it's not 2 nibbles, it's a nibble. We would expect the most significant digit, right? If we read 4 bits, we expect a 1 if we're going from the most significant bit. So here's an example of how it's going to fail because I cheated, right? It's returning, where does it show that? Here, it's returning 18 when it should have returned 1. So that means we have to actually use the AST, which is going to be a lot more work. So this might be a good stopping point. Basically, what we need the ingestion to do is use this AST and walk through the data with it. So the way it's going to walk through it is it's going to go do the statements in order, and it's going to say, okay, we're going to parse something. It's going to use this format, which we want to be built in. That'll use the bound to request that number of bits from the bit stream and assign it to the variable bar. And then the return statement will reference bar, and it'll pull those 4 bits out and return it. And then it should match what we expect because the number of bits will pass all the way into the UI function that we're going to define. You're welcome, the dev dad. Does that mean you're a developer dad or you're a dad of developers or both? Okay, so this is probably a good stopping point. When I stream next, probably tomorrow morning, 7 a.m.-ish Pacific time, what I'll do is actually start writing the engine that walks the AST in order and will only support part and return to begin with. We'll support references and we'll support the UI format. That's minimally what we need to parse this either as a byte or as a nibble, right? Then we can expand on this, like the format can take a parameter. The parameter might be like the number of nibbles and then, or the number of times to iterate. And then we'll have a loop. So our data will be a vector and it'll be a lot of fun. So I hope you'll join me tomorrow morning while we work on that stuff. Oh, you're welcome. I should probably record that as a YouTube video, right? Yeah, I think that lifetimes are more easily explained by starting with something simple. And this is a very useful, simple example of lifetimes. Basically, we don't want to copy the input, so why don't we just make a buffer that lives as long as the original, and we just hold a borrow to it, right? One of the simplest things you can do with lifetimes, I think. And it's immediately useful, right? We can ask for a certain number of bits. We can start remembering like their offset in the slice, and we can just like give them 1 bit at a time, which is exactly what I'm about to do tomorrow. Not about to, but what I'll do tomorrow is we're going to enhance this so that it remembers how many bits we've read before, and then when it asks for a certain number of bits, we're going to take the current byte and like chop off the bits we want and shift it the way so that we put it on starting at the top bit. And then it'll actually be a bitstream parser for a buffer that returns bits, and it'll actually be a very useful and reusable component. Coding Joy is goading. What is Coding Joy doing? Is Code and Joy on a break? Let's see. No, he's just not having a camera. Well, we're going to rate Code and Joy because I don't know anyone else who's streaming right now. See, Code and Joy is working on type-safe land, whatever that is. I guess that's TypeScript. I can't even read the text because the font is so small, but I hope it's interesting. I got to go eat dinner, or else I'll get in trouble from the family. So I'll be back tomorrow morning, 7 a.m. or so. So take care. Bye. Thank you all for watching.